All right. So we finished up talking about going over our basic simultaneous multiple regression using this accident dating car accident survivors, looking at the impact of PTSD, pain, and opiate use on role functioning types of things. So we went through, did the screening with this, all familiar with this data set and kind of what's going on. We're going to keep with this just because it's hopefully at this point you're kind of in a good spot in terms of thinking about where we're at with stuff, or sort of the relations between these different variables. On our simultaneous regression, remember the simultaneous regression is we're just putting all of these variables in together, and what we're doing is we're looking at the unique relation of this variable with the outcome. Okay. Here we're seeing that we are finding evidence for unique effects of pain severity and PTSD on the natural log of role functioning. Okay. If we go up here and look at the top, we're seeing that the best linear combination of opiate use, pain severity, and PTSD is accounting for about 38% of the total variability in our natural log of our role functioning variable. We see that our overall R squared, right? We have our significance tests here with a pretty massive F, telling us that yes, in fact, we do have evidence that that 0.381 is, we have evidence that that does differ than 0. That's what our F test is telling us here, right? And then down here, we have our individual coefficients. Looks like when we look at our bivariate relations, the opiate use does have an association with role functioning, but once we include and account for shared variability with other predictors, we find that it, in fact, no longer holds a unique association. So whatever shared variance opiate use has with our role functioning variable is already being accounted for by pain and PTSD. Once we account for that, it's no longer a significant predictor in this model, even though we do have an association in the bivariate case. Okay. Here we have our standardized coefficients. Remember that these are interpreted as standard deviation units. So here, if I'm looking at my pain severity score, I'm saying that for every 1 unit increase in pain severity, I'm getting a 0.685 unit reduction in the natural log of role functioning. Now, as we go through and talk about sort of the impact of that specific natural log transform on interpretation, given that we've transformed our outcome, we can interpret this coefficient to say that for every unit increase in pain, we're expecting about a 69% decrease in role functioning. For every 1 unit increase in PTSD, we're expecting about a 1% decrease in role functioning. Okay, so we've got some nice interpretive qualities here. Standardized coefficients, this is just a nice way to go through. We can't directly compare our unstandardized because everything's on a 1 unit change in our PTSD scale is a much smaller increment of change than a 1 unit change in our pain severity score. So what we can go through and do is take a look at our standardized coefficients and see how those are looking in standard deviation units. Here, we would say for every standard deviation unit increase in pain severity, we've got a 0.565 standard deviation reduction in the natural log of role functioning. Okay. So just thinking about being able to interpret those back and forth. Here we have our confidence intervals, and here we have our 0 order, our bivariate correlations here, and then our partial and our part. Okay. Remember our partial correlations, this is looking at the, if we square it, we can interpret this as the proportion of residual variability in our outcome attributable to our predictor after we control for everything else. So once we cut out the piece of the pie that's attributable to opiate use and PTSD, of what's left over, if we were to square this partial correlation here, that would give us the proportion of residual variability in the natural log of role functioning that we can assign pain severity. Our part correlation, remember this is our semi-partial correlation. This is going to tell us of the total variability in our outcome, what's uniquely attributable to that predictor in this model. So if we were to go through and square our part correlation or our semi-partial correlation, what this is going to tell us is it's going to say of the total variability in the natural log of roll functioning, whatever the square is, that percent is uniquely attributable to pain severity after we sort of control things out, okay? So again, we're looking at differences in the denominator. Think back to that that pie chart, or excuse me, that Venn diagram that we went through and talked about, okay? So just a quick recap on multiple regression. Any questions about this? I'm feeling comfortable with interpretations. All right, that's just that in Stata. Talked about, finished up last time talking about differences in log transform. My gripe against transforms is it takes our outcome variable that means something and turns it into a function that doesn't mean anything, or probably doesn't mean anything. But with our natural log transform, there's still like an intuitive interpretations that we can apply, which makes this a very desirable transform if it works out. Differences in the interpretation if we transform our predictor, transform our outcome, transform our predictor, or transform both. So just be aware of sort of what this does to your interpretations and thinking about how to apply this, as opposed to one, pretending that you didn't transform, or two, just sticking with saying, this is the effect on the log transform or the squared root transform, or something, sort of whatever it is that you applied, just because there's not a whole lot of interpretive value to that. All right. Okay. Jumping into our hierarchical regression. Okay. Different names for this: hierarchical or sequential regression. What we're doing here is we're entering variables into the model sort of based on some plan that we've come up with here, okay? So as opposed to our simultaneous regression, not everything is going in there immediately, but our hierarchical regression is, there's nothing fancy or new really going on here. It's just us layering in models and stepping that, layering them in sort of based on some sort of conceptual plan. We got a couple different strategies we can go with here. One, what we can do is we can enter in our variables or our predictors that have some theoretical importance and that we think are going to account for sort of the main stuff in the outcome. And then later put in sort of like control or nuisance variables or things like that. The idea would be to say, here's all our stuff that's important. We're going to put this in, look at this model, and then what we're going to do in the next step, we're going to throw in alternative explanations, other nuisance variables, things that people generally control for, sort of other variables that are important in accounting for our outcome. We're going to layer those in the second step and then kind of see what that does to our model, okay? So this is kind of a sort of a step forward type of approach, okay? Other possibility is what we can do is we can enter all those control variables in first. First block, all your control variables go in, all your nuisance variables, all the other things that you want to just kind of account for. And then the second step, you go through and put in the stuff that you're really interested in to say, does this account for things above and beyond just our general background characteristics, okay? It does not matter which way you do this. There is no sort of right way to do this, no wrong way to do this. This is completely has to do with how you want to go through and talk about your model, okay? Only difference between our hierarchical regression and our standard multiple regression is that at each step, we're going to get an R squared change, okay? And it doesn't have to be 2 steps. We can have 3 steps, 4 steps, however many steps you want, right? What's going to happen is you're going to go through and you're going to start with, let's say we start with approach number 2. We enter our control variables. Let's say we throw in participant sex, state, mood, and social desirability, and kind of throw those in and see what that looks like, insert those those associations with our outcome. Then in the second step, we've got our critical variables, whatever those are in our study, and we're going to go through, and in the second block, we're going to layer those in, okay? Now, at each one of these blocks, you're just running a simultaneous regression. It's just the first simultaneous regression is the regression with just all of your covariates, and the second one is just the regression with all your covariates plus all of your critical variables. And what this is going to do is it's going to say, here's the R squared with just your control variables, and here's the R squared with the full model. How much does that R squared change? And you're going to get an estimate of the R squared at each step, and the extent to which that R squared, we have evidence that that R squared change is different than 0. That is the only thing that you're getting that's unique out of these models. Nothing else. All of your coefficients will be identical as if you ran it with a simultaneous regression. With a hierarchical model, there's nothing fancy or magical that's going in. The only thing that you're getting out of these models is an R squared change. Okay. Yeah.
In terms of which step you use, so if you're reading a study and it says and it uses the word like predicted over and beyond something, can you assume that they use that second strategy, or could they have still used the first strategy too? Or does it not matter?
That doesn't matter too much with that. It's just looking at what that first model is. Basically, you're just comparing different models here. It's just you're comparing a series of simultaneous regressions. The first model is whatever went through in the first model, and the second model is just, or in the second step is just a second model that has all the stuff from the first and then all the stuff from the second. Is no different than if that's the variables in that second step, or the coefficients that second step are no different than if you would have just ran a simultaneous regression with everything in there in the first place. They're identical. They're the exact same. The only thing that you're getting is that change in your overall model R squared from the first model to the second model. Okay. Yeah.
If you're like your series of like R squared, you're like visually expecting to be that like sufficient to be like these values are different, or is this a formal test?
No, there's a formal test for this. Okay. So here, let's say what we're interested in is the incremental contribution of pain severity, the prediction of functional outcome above and beyond medication use. And then we want to know what's the incremental contribution of PTSD symptoms, the prediction of functional outcome above and beyond medication use and overall pain severity. So what we're doing here is we're going to set up a 3-step hierarchical model. Now here we've only got one variable in each step. You can have however many variables you want at each step. You only have 3 predictors in this data set. So we just step them in incrementally. So here what we're going to do in SPSS, we're going to go to analyze regression linear, and then block 1, we're going to drop in opiate use. Block 2, we're going to drop in pain. Block 3, we're going to drop in PTSD. And then if you go to statistics, you're going to ask for R squared change and part and partial correlations. Okay. This is all outlined in that handout that you have, so it's pretty simple to walk through in SPSS. Okay. So what you're going to get here is your model summary. Okay. For if you were to just run this as a standard regression model, right, with pain, PTSD, and opiate use as your predictors, you're just going to get your R squared, right? You get an R squared of 3.381, your adjusted R squared. So we're all familiar with that. Your hierarchical model, with each one of these variables entered at different blocks, you're going to get 3 rows here. Your first row, and if you look at your subscripts down here, this is just your model with opiate use. Okay. When opiate use is the only predictor in the model, you get an R squared of 0.051. How can I get that? If this is the only variable in the model, what is that? What is R and what is R squared? You've only got one variable in the model. What does that equal to?
It's just a correlation between opioid and...
Yeah, it's just your bivariate correlation, because there's only one thing in there. You've got a simple bivariate regression model where you've just got one predictor. So in this case, the special case, because there's only one predictor, your R is your Pearson correlation. Your R squared is just that Pearson correlation squared, right? But here what we get is R squared change. I guess it went from 0 to this, and then you're going to get your test of whether or not that's better than 0, right? And so you've got a test here. Second line, this is your model with both opiate use and pain severity. Here we've got an R squared now that's 0.355, and an R. And if we go through and take a look at this, this is just get this by simple subtraction. The R squared change is increased by 0.304. Okay, Then we've got a test for our R squared change. Sam, this is saying, do we have evidence that this is sort of an increase? Really huge F value. And so, yep, we have evidence that yes, including pain severity into this model does account for a greater proportion of variability in our outcome above and beyond just having opiate use on its own, okay? Step 3, this is our model now with opiate use, pain severity, and PTSD. Getting an increase, but it's a smaller increase. We go from 0.355 to 0.381. That's an R squared change of 0.026, right? So we've got an additional 2.5 percentage points in terms of proportion of variability accounted for. But if we go through and look at our F test for change, yeah, we still have evidence that this is accounting for greater variability above and beyond. So yes, in fact, having everything in that third block is increasing our model R squared, okay? So this is cool. This is interesting information. Only thing that comes up is we don't often care about our R squared in our studies. It's generally not what we're trying to maximize. We should think about it more, but in terms of does this account for variability above and beyond, it's sometimes not a question that's most pressing for the types of things that we do. Now, let's say if Josiah, you're running some stuff and you're saying, hey, everybody's talking about this and that, and these are all of the variables that we use to predict our outcome. But I think what people are missing is this one thing. Now, this one thing is kind of related to these other things, but I think this is a distinct construct that if we were accounting for this, it's going to account for more variability. It's going to better explain our outcome. And so maybe what you would do in that scenario is you would go through and enter the standard stuff that everybody always includes when they're looking at this in the first block. And then what you might do is in that second block, add in your pet variable or pet variables to say, if we include this, does it improve our model? Do we account for more variability in our outcome? In that situation, I could see someone making a big deal about this, saying, yeah, when we include this in, it's accounting for stuff that's not already being addressed with the standard approach that we're using. It's increasing. And if it increases your outcome by quite a bit, then that's pretty impressive. So there are times when you might use this, but it's just not something that is generally the focus of what we're doing, okay?
Incremental regression makes sense as like incremental validity.
You can make an argument for incremental validity. Does this come in? But you could also just look at your coefficient for simultaneous regression and say, does this individual thing predict outcome above and beyond everything else? So where this starts to become interesting, maybe, is if you have a set of variables that you're making an argument accounts for additional stuff. Let's say I've got SCS variables that people don't ever think about, but I'm saying this collection of indicators is going to help us better explain some phenomena. And so then it's gone beyond just a single predictor, it's a set of predictors. That's where you might use this a little bit more efficiently. Okay. Questions on this R squared change concept? All right, our ANOVA table, again, for our standard regression with all three predictors simultaneously, you got your ANOVA regression here, right? Or your ANOVA table here. In your hierarchical model, you're just getting 3 ANOVA tables. This is your ANOVA table for just the one predictor, the ANOVA table for your two predictors, ANOVA table for your 3 predictors. Well, Asha, by the time you get to the ANOVA table for your third step, what do all the coefficients in here look like? What's that? How do they relate to those in your simultaneous regression? What's that? Yeah, relate really well. How do they relate? Yeah, it's all the same, right? Because this is just your ANOVA model with all 3 predictors, okay? Again, just going back, there's nothing special going on in your hierarchical model. You're just running a series of 3 models. You're running a first model with just the 1 predictor, a second model with just 2 predictors, a third model with all 3 predictors. It's going to be identical to your model that you just ran with everything in there in the first place, okay? So nothing changes here. Same thing with your coefficients. Here's your standard regression. We've got opiate use, pain, and PTSD going on here. You look at your coefficients table from your hierarchical model. Your first sort of group here just has opiate use. The second has opiate use and pain. Third group has opiate use, pain, and PTSD. Emily, how does at step 3, how do those coefficients compare to your standard regression? Yeah, how do coefficients at this step 3 relate to your simultaneous regression? They're all the same because there's nothing fancy going on. What happens is people get this confused with stepwise regression models and sort of the presumption that sort of if I put things in the first step and the second step, that those somehow get priority for things. That's not the case with your hierarchical regression. You're just running basically 3 regression models and comparing the outcomes of those 3 regression models. By the time you get to the third one, where you've got all the same variables that you had in the first, it's literally the same thing. There's no difference. It's done the exact same way. So the only thing that we're getting with our hierarchical regression is that R-squared change. Now, there are presentational reasons where this might be advantageous in trying to organize kind of what's happening, particularly if I have a large number of variables. Say conceptually, I'm going to put these variables in first, then I'm going to add in these other variables, kind of looking at these third domain, and then I'm going to add in these other predictors, and so then I'm going to have a full set of stuff going in. But there's nothing statistically or analytically going on different as aside from comparing the R-squared from the first model to the second model and the second model to the third model and seeing how things crank up. Okay. Everybody clear on hierarchical regression, what we're doing here? All right. Just some different syntax and stata for going through, pulling up some different tables and things like that. So for stata users, you got that in the handout. So just kind of setting these up a little bit different. This is going to get us to our final piece here, which are stepwise regression. Stepwise regression or statistical regression. This is where people get confused and think that this is what's going on in your hierarchical regression. With a stepwise regression, you have predictors that are entered or removed based on some incremental association with your outcome, okay? Depending on this type and the way you've gone through and set this up, generally what's happening is you've got all of your predictors with the greatest absolute correlation start getting entered first, and then variables start to be added or subtracted based on their incremental contribution to your outcome. Okay, and then if you have variables that aren't meeting some threshold for entry, those end up getting pulled out of the model. So for your here's our regression that we sort of know and love, right? And here we've got 3 outcomes. If we go through and we run these A, B, and C predictors, got A gets credit for this because that's unique to A. B gets this piece because that's B. C gets this piece because that's C. And these are the regions that are captured by our regression coefficients, right? Here, blue areas. Where do we see credit for those areas? Where does that come into play? Yeah.
Like indistinguishable from A and B and then
Yep. So we can't tell. So it's all shared and overlapping stuff. Where do we? So does the model not? Do we not include that shared variance in the model?
whichever one of those factors you put in.
Nope. Nope. That's that's not to shout nope at you, but that's the assumption that people will sometimes making, sort of getting this crossed around.
Like where is it showing up?
Yeah.
Like your overall, like.
Yeah. This is just going in. R squared counts for all of those, but your individual predictors only captures each one of these, okay? And then if you're looking at your part and partial correlations, you know, are we talking about variability in all of this or variability after pulling some of these things out? This Venn diagram is your best friend in trying to understand what's going on with your regression models.
For this example, would you argue that he is obsolete or redundant, or because it's capturing that little unique portion that A and C both aren't, that's allowed to not be redundant?
Between what?
So like, B is capturing like that little portion that's just
Yep.
A alone, is that what allows it to not be redundant?
Yeah, because otherwise, what you might find is just in the bivariate case that B has a pretty good association with this. What you might find is once you go through and add A and C into the model, B might not be a predictor, a unique predictor of outcome. I mean, it's got something, but our test says that we don't have evidence that that's different than 0, right? And so B could fall out completely, right? Yeah.
So like conceptually, is this kind of like our ANOVAs?
Kind of like ANOVAs, and ANOVA is just a special case of regression, so it's the same thing. The thing that happens in ANOVA and sort of that tradition is an experimental tradition where you have randomly assigned conditions. And in that case, we should have, here's my outcome. And these things are orthogonal. The conditions are unrelated to one another, so there can be no shared variability in that, right? But yeah, any ANOVA we can run in a regression model. It's just, ANOVA is just a special case of the general linear model. And so if we code that correctly, we can run any ANOVA in a regression format. And if you have, in programs like STATA, if we have violations of homogeneity of variance or weird violations going on in that, you can take that ANOVA and run it in a regression environment that uses a different estimator that accounts for some of that stuff. So you can move back and forth with this. Yeah.
And then when thinking about like the standard regression and then the hierarchical regression, like can we think about that kind of like ANOVA too? Because like with our ANOVA, a lot of time we wouldn't know the direction or we wouldn't know like which variables that we would need to do t-tests. So like with the standard regression, like conceptually, essentially be like what our t-tests do, and then
Yeah, I mean, so basically, in what we'll get into when we look at modeling categorical variables, what you would do is, let's say I've got three conditions. I could have a control condition and then create dummy codes that identifies condition 1 and separates it from, or condition 2 separates it from 1 and 3, and a dummy code for 3 that separates it from 0 and 2, and then, or 1 and 2, and 1 is my baseline, and then I just go through and I run that and code that. And what it's going to give you is in your coefficients, it's going to compare control to 1, control to 2. Your overall ANOVA is, or your overall R squared is going to be the same thing as your eta squared from your ANOVA model. It's, yeah, I mean, so depending on how you code those variables, it's going to set up different contrasts, but your overall test of your R squared in that case is going to be equivalent to your F test from a one-way ANOVA model. So as you start to get more complicated models, you have to be careful on how you're going through and coding things, but it's all the same thing. Okay. So this is what's going on with our standard regression that we will use. Questions about this? Okay. When we go into stepwise regression, here we've got this. And what we do is we look to our possible predictors and we say that Z has the most, the biggest bivariate correlation with our outcome. And then we've got something different with X. And then also, we'll say, like this is Y. Okay. Here, if Z in the bivariate case had the strongest sort of association with our outcome, all of this goes to Z. Z got put in there first, Z gets everything, okay? And then if Z is the first one at the party, everybody else is just looking for scraps here, right? So here we've got X gets this, because this is X. And then Y, it's got that, just that little thing. Y might not even get included in the final model if it's not associated with a small p-value. Y just gets kicked out. So we're just left with X and Z. Even though Y does share a great deal of variability with its outcome, Y doesn't even get included in there, okay? And this is what's going on with when people are thinking and making Amanda the mistake that you had made in terms of thinking about the difference between simultaneous regression, stepwise regression, this idea that, okay, this variable got put in first, and so then it gets all of this stuff, and then everybody else is left to fight for scraps. This is how we set up these stepwise regressions. These are rarely conducted in our field for good reasons, okay? Controversial, okay? So these models have no theoretical basis, right? We're just throwing stuff in the hopper and seeing what turns out, okay? I have no idea, I don't care why variables are related to the outcome. I just care that they do predict, and so I'm just throwing stuff in there, okay? And you often see with this lots and lots. I might have 20, 30 predictors that I'm just kind of throwing in there to see what happens, okay? Because it's atheoretical, I don't care. I have no reason to expect these things. These are just the data that I have to try and predict some outcome, okay? Our final solutions can here sometimes be dependent and are often going to be dependent on some trivial or sample specific variation. Let's say I've got two variables. I've got, in my sample, variable 1 is correlated with my outcome 0.34, and in my second variable is correlated 0.33 or 0.32. Which one gets put in there first? 0.34, okay? Is the correlation of 0.34 and 0.32 meaningfully different, conceptually different, right? No, and in this model, variable 1 looks like it's the main predictor and it's the big thing going in, right? And variable 2, depending on what else is in that model, might not even be included. I would go through and I run a replication and run this again, and now all of a sudden it's switched. Now I've got a completely different, I've got variable 2 that's correlated 0.34, variable 1 is correlated 0.32. Now variable 2 gets thrown in, variable 1 isn't even in there, all because of a trivial difference in sort of bivariate correlations on the front end, right? And so replicability of these models tend to be poor just because of the way that things are entered into stuff. Final thing that happens, these solutions tend to overfit our data, right? Because they're capitalizing on chance and sort of small incremental deviations and things like that. Again, they're not replicable, and it's unlikely if you were to run this again, you could get a completely different sort of model, sort of based on just sort of nuances of the data, okay? So there are ways to go through and do this. And if I was in marketing or econ or an area where predicting some outcome really is, Amanda's got a store. She's just trying to predict revenues for her company for next year. That's all she cares about. She's not kind of trying to contribute to science. She's not trying to identify unique theory-driven associations between anything. All Amanda needs to do is best predict her outcome to be able to sort of budget and things along those lines. It's a fair enough model, right? You just dump things in and say, okay, if I go through and throw all this stuff in, I can predict my outcome, 75% of my revenue outcome for next year. Cool. I don't care what's in there. All I know is this is what I can start plugging in and start sort of making predictions based on that. Fine. But this is not the type of model that you'll generally see in our field. And if you do see someone using this, it should raise some red flags in terms of the atheoretical approach, questions about replicability, so on and so forth. Okay. Questions? Yeah. What's up?
So it's like you care about zero order, and that's sort of like where you start. That's sort of like what we
Yeah, and it kind of depends on sort of the system, and there are different types and sort of procedures and things like that. But in general, yeah, you're on the right track with that.
This is more concerned with like trying to account for as much variability in the model as possible. That's the situation don't have like.
Yeah.
You don't really care.
Yeah.
And then, so this is also disregard like linearity.
Yeah, I don't care. Because again, remember that collinearity impacts does collinearity impact our estimates? No, well, it impacts our standard errors, right? And my standard errors are only important if I'm looking to gauge evidence for against something. Is like, if I care about a statistical test, then I care about standard errors. But if I don't, if I'm just predicting, care less about them. Because my point estimate for the effect is unbiased. It's sort of that inference test that starts to get thrown off, right? So here, again, not worried about it, throwing everything in. And with these types of models, if we're just throwing a bunch of stuff in indiscriminately, sometimes you can get collinear to the point that it crashes everything. And then you're like, oh, whoops, what's going on? Let's sort of pull this person out or this variable out and see what happens. Yeah. So it's a very much kind of a machine, sort of like, it's not machine learning, but it is like sort of just kind of throwing to see what turns up.
This isn't really like an exploratory situation because you're not like gonna replicate in those cases, like it's not really gonna, we're not gonna have a situation. Probably better off with machine.
Yeah, and that gets into a whole sort of situation with stuff. Yeah, I mean, there really is, it's hard for me to come up with a scenario where this would be an appropriate model to run in our field, but want to cover it, talk about it, bring it to your attention so you know what's going on with these variables. Because again, if I go through and I were to compare a simultaneous regression model with a stepwise regression model, it's apples and oranges, right? Because pain goes through and pain gets the coefficient for pain is going to be way big because anything that overlaps, pain overlaps with other predictors, doesn't matter. If pain got first, pain gets all of the pie, right? So even that, like trying to compare strength is going to be different because it's going to depend on how people and how variables got entered into the model. And so it's kind of a completely different beast. Other questions? All right. So I'm going to finish up with some practical issues. Thinking about our model selection. Garbage in, garbage out on this. We need to be thinking carefully about what variables are going into our models. Again, sort of our high sort of criteria for our regression model going to be most efficient if I've got X's that are maximally associated with our outcome and minimally associated with one another, right? That's going to be our most efficient and least redundant model. Our goal here is to, in terms of parsimony, what we want to do is account for the most variability in our outcome, sort of account for what we're looking to account for with the fewest number of variables, which is the opposite of what we're doing with statistical regression, right? Wanting to think carefully about the quality of our variables, sort of the measurement properties of our scales, reliability and things like that, because the more junk that we throw in there and the more sort of static that we throw in there, it's just going to go through and degrade our models, our estimates and things along those lines, right? Now, a lot of times we're using these correlational techniques with pre-existing data, it's secondary data analyses, and we're kind of stuck with the variables that we have, right? But if we're not, if we're setting up a study specifically for a regression-based analysis, what we should be thinking of are what are the important variables. I'm thinking about my literature when we're talking about this outcome. What are the things that we know should be related to that outcome? What are those list of things? What can I measure? How should I measure? How are these things related to one another? Because I don't want to throw in negative affect and neuroticism and BDI and sort of like every other distress variable to predict some clinical outcome, because then it's all going to be stacked on one another anyway, right? So thinking carefully about what goes into these, what we're missing, and thinking about the potential consequences of that. Okay. Also thinking about sample size. Everybody wants to know, like, how many people do I need for my regression? Lots of rules of thumb. Rules of thumb are garbage. It just depends on so many different things. How many predictors you have, sort of what your criteria are for identifying effects, how big your effect sizes are, right? How much power, how much do you care if whether or not you sort of miss something and make a type 2 error. If we start thinking about situations, which often happens in our field, if we've got outcomes that are non-normal, right? If we have small effect sizes, if we have problems with the reliability of our independent variable, remember that our assumption, one of the basic assumption of regression, that we're measuring our predictors without error, right? We're never going to do that, but we can get closer to that than if we're, so this is a problem with making up your own scales, right? This is a study specific scale. It's not necessarily bad. Sometimes we have to do it if there's nothing else there that actually measures what we're trying to measure, but we should be thinking about what is the impact on my model if I'm sort of using an instrument that has no known psychometric qualities. I don't know reliability, validity, and things along these lines, right? Starts to become problematic. So always run a power analysis. And for our field, right, probably if you don't know, if no one's ever looked at it, you should probably just assume that you're targeting a small effect size. So I would rather have someone come in and say, hey, effect size is probably small. Here's what we can feasibly achieve. This is what the consequences for power. We recognize this with clear eyes going in, and so this is what we're doing. I would rather see that than someone say, well, we think about like, I can get maybe 70 people. So if I have 70 people, I can detect a large effect size. So I'm going to assume a large effect size to justify my sample. If you have no basis for assuming a large effect size, there's no reason you should, right? Most of the stuff that we're looking at is consistent with small effects, because a lot of times the effects are small and our measures are dirty and imperfect, and all of that adds in and starts to degrade the power of our effects. So hopefully there's a basis for going through and looking through the literature and saying this is generally kind of the size of the effect that people have found with this, and then be able to run a power analysis with it. But all the same stuff we talked about power last year still apply this year. If we don't have any good guesstimate for sort of what effects that we're, the size of the effects that we're looking for, we should probably just assume they're on the small end of things. Okay. All right. Questions? All right, cool. So, doing good. And for regression stuff, so here in the handout that is posted up here or on Wild Courses, you've got just all of the stuff going through the examples that we gave in class. Here's your simultaneous regression. Here's your hierarchical regression. Okay. Here's the write-up that we had talked about. So this should give you everything that you need to work through the problem set. But if you have any questions, track me down. Happy to go through it and help out with that stuff. Okay. All right. Now we get into the good stuff. All right. Moderation. Okay. So a lot of stuff that's going to go into sort of working through these moderation models, trying to figure out like exactly, so what are the steps that we need to go through, or the parts come together, what are the considerations that we need to be keeping in mind. Strongly recommend as we're going through this, having just a list of saying, first I do this because X, then I do that because X, to go through. This is going to be one of these situations where it's going to require you to work through steps, know what steps you need to take, and then also be thinking about, how do I know if what I've done is wrong? I've been doing I've been doing these, started in grad school in 2004. 2006, 2007, I still screw this up all the time, right? I'll go through, make a silly error, sort of add something as opposed to just subtract something, and then have to go through. And this is why we're going to walk through fail safes. This is why it's very, very, very important to kind of understand what's going on and knowing if I go through and I make an error somewhere, which I will, how I catch it and know that I've made that error, so they don't sort of move forward 7 steps before I then like, oh, whoops, yeah, I screwed that up. Now I have to start back at the beginning. Also, maintaining good syntax files is going to be very, very helpful with this. It's going to, once you get that down, you're going to have like basically a template for this is the process of me going through and doing this. So would strongly recommend having good syntax files, keeping notes in there, telling yourself, I did this, this is why I'm doing this. It'll pay dividends on the back end of stuff. Okay. So we're thinking about our regression models, right? Regression models are great. Regression models are flexible, but after a while, sort of the question is looking at the unique effect of X on Y kind of, is it interesting or informative, right? If, say, from our area, in my area, looking at is PTSD associated with social support? Yep, it sure is. Like I can only do that so many times before that starts to become boring. I haven't done anything interesting with this because everybody knows that it is. And so in my set of PTSD is related to social support, no one cares anymore, okay? So 1, it can get boring. And then 2, our coefficients are limited in what they say about the relationship between X and Y, right? It says, yes, these 2 things are related, but the question is are these always related, always in the same way forever and for always, okay? If I see that X and Y are related in the population and we've got meta-analyses, it's very clear that these 2 variables are related. Maybe the next thing I start asking about is, well, what are the boundary conditions for this? Is this always relate to X? Does X always relate to Y in the same way for all people, under all conditions, in all situations? When we start asking in terms of conditions under which this holds, it starts to give us more information about the phenomena of interest. And we can start to say, yeah, X and Y X relates to Y under X, Y, and Z circumstances. But once we get to this point, this kind of starts to break down, right? This can be a very, very, very interesting way to start thinking about more in depth about some of the associations that we're interested in, okay? And if I'm asking the question, how do these other variables impact the nature of the relation between X and Y? We're talking about moderation, okay? This is a process we've got some third variable. It starts to change the nature of the association between X and Y. This isn't news. We've talked about this before in our means-based analyses. Anytime we're looking at an interaction, whether it's an ANOVA, repeated measure ANOVA, we're talking about moderation, right? We're saying this is the association between 2 variables, and this changes depending on some third factor, okay? So within this model, our moderator is going to be any variable that impacts the magnitude direction of some relation. We typically draw this. This is kind of like the classic diagram of moderation, right? Here we've got X is related to Y, but we've got M coming down and kind of punching that line there. It sort of starts to change it, right? It changes either the magnitude and or direction of that association. So for example, we could say that the impact of stress on physical health depends on the degree of social support available to people. We know stress is bad for you, right? Stress is not good. It sort of has all sorts of physiological impacts, right? But does stress have the same physiological impact on everybody across the world for always and forever the same way? Probably not. There are probably some sort of person level factors that start to change the nature of that association. So we might say social support, like if I'm completely isolated, does stress have the same impact on my physical health as if I'm someone who has a good support network, so on and so forth, okay? What's the relation between psychological distress and substance use? Is it different across men and women? I don't know. Katie, is substance use, the relation between distress and substance use different across men and women?
Probably.
Okay, maybe. I don't know. I thought maybe you had a good answer for that was known in the universe. But if we if we stress somebody out, if we make someone upset, and if we look at and they're prone to maybe substance use, do we see that men and women differ in terms of how they use substances, just in like sort of Western US culture in terms of sort of norms and things along those lines? Does it start to change the strength of that association? Okay. So again, these are both moderation questions, right? And so what they're looking at is looking at conditions where this association is strengthened or weakened, or this is changed, okay? And so what we say, if we do find evidence for this, thinking back to our language from our ANOVA stuff, right? We no longer say that, oh, X has a direct relationship with Y. We say that the relation between X and Y is conditioned on M. It depends. Condition just means depends, right? So if I say, what's the relationship of stress and physical health? Emily, you have done sort of animal sort of neuro sort of types of stuff, right? If I'm looking at the impact of stress on health, you say, I don't know. It depends on these other factors, right? So again, you would say the impact of stress on health is conditioned on some other variable. So historically, what we've done is looked at effects between interactive effects between sort of categorical variables, looking at this in ANOVA models, which is what we did the whole first semester, and then a little bit at the start of this spring semester. Okay, so I wanted to look at the interactive effect of biological sex, if we say sort of men, women, and if we sort of dichotomize racial ethnic identification, we have people who identify as white, people who identify as black on social bonding. Maybe we have cultural sort of differences. We say cultural influences on men and women, cultural differences across black and white communities on social bonding. And we're just going to look at this in a 2x2 ANOVA, right? We've got groups, easy peasy, good to go, right? But if we start looking at and wanting to look at interactive relations that involve a continuous variable. So let's say I want to look at the impact of biological sex, sort of men, women, and SES on institutional salary, right? Like, do men and women make different amounts of money? Yeah, we know there's a gap there, right? But does that change depending on whether or not we're talking about people coming from high SES backgrounds or low SES backgrounds, right? Problem is SES a categorical variable? No, it's a big continuum, right? With our ANOVA models, we're kind of stuck because there's not a good way to deal with this, right? What we've traditionally done within these analyses is artificially dichotomize these continuous variables. So what we're going to do is we're just going to run a median split on SES. We're going to say these folks are high, these folks are low. Now we've got a dichotomous variable. It fits nicely within our ANOVA model. Okay. The problem is, if anybody has people keeping up on their paper article readings, if not, that's fine. I understand there's lots of stuff going on. You want to keep going on that, though. We talk about artificially dichotomizing these and what this does statistically. We lose power. We potentially bias effects, right? When we take something that's continuous, that's a continuum, we go through and say, here's high and here's low. You've got all those folks on the boundaries, right? Let's say Amanda and I make very close to the same amount of money. Elizabeth makes nearly no money. Basha is a bajillionaire, right? But depending on where that split is, Amanda and Elizabeth get grouped together. I get grouped with the billionaires, but I'm not good and I'm not representative of the billionaires. Like, my data is weird within this sort of group, right? And so we start to get weird effects. We start to decrease power, right? Because we're not using all the information in the scale. We're just cutting it out and sort of having sort of the average of these two groups, okay? If, however, we go through and take a regression approach, what we can do is we can start to look at interactive effects with any combination of continuous and categorical variables. Categorical variables get a little tricky depending on the nature of those categories, kind of how many we have, but we can go through and code these so we can look at sort of the extent to which this categorical outcome moderates the relation between this continuous outcome and this continuous predictor and our outcome across the whole range of the scale. We've retained all the information. We've retained all the values. We haven't artificially put people into groups. It ends up being resulting in a much, much more appropriate model, and starts to capture associations that are probably should get closer to what actually is going on in the world, right? And you might say, Josh, but like I went through and I ran this with a continuous interaction model and it didn't work out, but then I did a median split on some stuff and things turned out the way I wanted it to. Like, well, sure, but that's probably not actually reflecting. Probably what you're doing is capitalizing on some aspect of those data, right? And if it didn't replicate in the continuous moderation, I would be concerned that you haven't just identified a statistical artifact in that, right? Because this should be a more powerful approach to testing out and teasing out interactions or moderation. Okay. Yes.
So we said before, when you use regression models, like that increase the number of participants.
Yeah. Anytime we're using a more powerful model, right? Now, sometimes, again, because, and this starts to get into, and this isn't like people are just doing bad stuff, right? And I think sort of if we go back to the roots of psychology, it's a lot of social psych folks and sort of cognitive folks. And so it's a lot of studies with experimental studies, right? Like, you know, you had Skinner who's got like sort of 15 rats looking at something like that, right? Because that's kind of what was going on at the time. We've just advanced sort of mathematically and computationally to such a point, there's really no reason to do that, right? And we have packages that will go through and sort of run these analyses appropriately. And so you'll see nowadays it's going to be really hard if you have a continuous variable that you artificially sort of median split it just because of no reason, just because that's what I decided to do, because I could run an ANOVA model. You're probably not going to get, it's probably not going to be well received in terms of reviews by sort of reviewers and things like that, just because there's a better way to do it and there's no reason not to. Yeah. What's that?
You get stuck with like a dichotomized variable that like doesn't make sense to dichotomize in the first place. So like, for example, for like, to say like the variable is like, you have all of these systems, right? Versus don't have all of them. And that like totally should be something continuous theoretically, like might have some, and you're falling into like the zero.
Yeah.
Versus one. Like in those cases, does it kind of make more sense? Regression versus like in ANOVA, you should theoretically like have a coding variable that's distinguishing between like definitely two distinct populations, and so it's like a theoretical issue.
Yeah.
Where it's like if you're stuck with it, then like you should definitely use it.
It depends. It depends, right? Like, so a lot of times we're stuck with the data that we have. And if the option is to not do our analyses or to do it with suboptimal data, we'll probably just do it. Because a lot of times we don't have control over that, right? Sometimes situations where about, so that some of the stuff that she works in her lab in terms of suicidal ideation, if you just ask about to the people in general, you get a whole bunch of no's and then something kind of strings out. In that case, you know, maybe is ideation a continuum? Probably. We think about like just like kind of passive thoughts of things to sort of an active plan and sort of along those lines. But in that case, we might just say we got 75% of our sample who just say no, and then everybody else who kind of strings along. Maybe I dichotomize there. Now there are probably other better ways to do it that account for those types of variables that are probably advantageous. But in that case, if you're that's sort of above your pay grade and you don't sort of really know how to do those, like you could make an argument for, okay, I'm just going to sort of dichotomize this. It's not great, but it's something that you could do, right? So long as you can sort of kind of make an argument for this is what I did and this is why I did it. These are the data that I have and it's a limitation of the study, right? And then it's up to people to decide whether or not it's a fatal flaw or something that's suboptimal, but at least sort of we still have evidence or sort of information that's useful with this. So always remember that in here, I'm speaking from sort of a best practice, like this is in a perfect world, how we would do things. And this is maybe what we should aspire to try and think about before we collect the data and then figure out we got a mess on our hands on the back end. But in day-to-day life, we sometimes have access to data that just is. And so then what do we do with it? That's 100% sort of the job of applied data analysis, is to trying to figure out like what's the best way I can go through and approach this and sort of get something that's reasonable and interpretable, that minimizes the drawbacks and maximizes the benefits, right? So all things to be thinking in your mind, right? What I don't want you to do is to go into your labs and say, Josh told us we could never do that. And then your advisor's mad at you and mad at me. And so what you could do is you could say, boy, I think this is sort of a reason that this might be problematic, or sort of starts to muddy the waters in what we can interpret. But at the end of the day, you know, it's kind of doing the best with what you've got. All right. So going to use the same, yes.
Sorry, quick question. So then, so would it be like an over moderation regression, right? Not verified. So we're like visualizing it by like, when we're doing it now, does it make sense to visualize bar graphs versus when we're doing regression, we care about slope, accelerated
Yep.
line?
Yep.
Like you can do either way.
You can do either way. Visualizing it makes more sense to sort of, I think, because the other thing too is people will, and you will sort of make the mistake of talking about differing levels. There is no differing levels in continuous moderation. You're looking at differences in the strength of a relationships across. So you're going to see like the endpoints of your simple slope graphs and be like, oh, is this different than that? That's rarely an interesting question. I say rarely. I've published a paper. One of my first papers was I was looking at sort of whether or not the endpoints, but it was for a medical journal, and they we're going to want to know about that stuff. But the thing is, those endpoints aren't real points. Those aren't actual observed values. Those are just model implied points at those two. So you really start to get into sort of a question about whether or not that makes sense to compare sort of things at these ends that sort of might not make any difference anyway.
Yeah. Ask if we're gonna at some point. Like I've seen that like whole like probing the bottleneck.
That whole what?
Like the whole, when you're like going to probe your moderation, people are like, oh, like, we're looking at the
I mean,
slopes actually.
yeah, I mean, there's the whole, and your factorial ANOVAs are no different. You're just looking at associations between categorical variables and outcomes, right? It's easier to visualize if you're thinking about mean values, but those mean values are oftentimes observed. Like, yes, this is the mean of this versus the mean of that. Here, it's saying like, given sort of this set of variables, I would project this to be the outcome based on the model. But particularly if my model's not accounting for a whole lot of the variability in my outcome, it's going to be a ton of error around that. So I'm comparing a hypothetical against some other hypothetical, right? Which may have value, but oftentimes won't. Okay. All right. So talking about moderation here, we're going to use our same set that we've been using up to this point. Again, looking at, I didn't natural log roll functioning. This is just roll functioning. We're just pretending that didn't happen. So, but it's fine. It doesn't change too much. But here we've got the same variables. We've got pain, opiate use, and PTSD. And what we're doing here is what we want to know. Our questions now aren't, what are the unique associations of these predictors with our outcome? We're getting a little more nuanced. What we want to know is, do opiate medications influence the impact of physical pain on roll function, right? Does whether or not people are taking opiate medications, does that change the nature of the relation between my level of physical pain and my level of functioning? Okay. We've got the second question here. Does pain severity change the nature of the relationship between PTSD and roll functioning? So PTSD is associated with poor functioning. Does it matter sort of the severity of pain that I'm experiencing, right? Is the association between PTSD and pain contingent on physical pain that I've sort of developed since this accident? Okay, so we've got a couple of moderation questions, same set of variables, but we're just going to reconfigure this this regression model and start asking some potentially more interesting questions. But before we get there, we're going to go off. We're going to talk about centering. Okay? Centering. If we go through our center our variables, what we're going to do is we're going to rescale all of our predictors so that the mean of those predictors is equal. Okay, remember I told you that 0 is a magical number in regression. Okay, Zero, it's always important to know what zero is, what zero represents. And what we're going to do with our regression models is we're going to go through and take all of our predictors, not our outcome, our predictors, and we're going to rescale those so that the mean of the predictors is equal to zero. And this is easy to do. We're just going to subtract each score in the sample from the sample mean, okay? So we're just going to go through, we're going to run our descriptives, say what's the descriptives for this, and then I'm just going to subtract the mean from that, right? So all items, all scores get subtracted from the mean. What happens now is the mean of my sample is equal to zero. My standard deviation, though, doesn't change at all, right? I'm just going through in my uncentered data here. I've got a mean of 5.6, a standard deviation of 2.3. So if I have a score of 5.6, I'm standing right here at the mean of the distribution. This is me hanging out on top of that. If I go through and I take all values in the distribution and I subtract them from the mean, this is going to give us our centered variable. Here, if I'm sitting down here at zero, right? Zero's here. Here's my mean of my sample. Once I center, zero is now here. That value that was zero is now at negative 5.6, right? Zero is now the mean. Sort of this person, sort of at 10.2, is now at 10.2 minus 5.6, so they're going to be right there. The shape stays the same. Everybody's position stays the same. This is not a transform. We're just rescaling this variable so that it has a mean equal to zero. And this starts to become important because when we're looking at our regression models, remember when we're saying that we're controlling for an outcome or sort of we're accounting for an outcome, basically we're saying that this is the predicted value of our outcome when everything else is held constant at zero. In our raw variables, zero might be a meaningful value. It might not be a meaningful value. It might not even be a real value, but it's saying that we're holding everything constant at zero. Now, in our simultaneous regression, that doesn't make a difference. Everything kind of stays the same anyway. But when we get into our moderation analyses, where zero is starts to make a whole lot of difference in terms of our interpretations. Okay. See what we're doing with centering?
I do see that, but I am curious, like, how is this different than a transform or a transformation?
Transformations, these are nonlinear transforms. If you go through and center a variable, the distribution is the same, everything's still the same. A transform, this is a nonlinear or sort of tweak to your data. So we're taking wherever we're taking a log or something along those lines. It's not a linear transform. Anything. So if I were to go through and say log transform my outcome and run through that, means very different coefficients. If I go through the center, it's not going to be, the coefficients are always the same, at least in a simultaneous regression. It would be in the moderation.
So for this, the centering, I'm just trying to think about like when you do this.
Always.
Are you doing it in the screening or like with the analysis or like where?
Yeah, I mean, it won't make it have an impact on your screen. You do this after you go through and screen, then you would go through and center with stuff because centering won't have any impact on your screening.
Okay.
Yeah, it's not going to change the nature of your associations. It's not. And for the set that you're working on right now, don't worry about centering. You don't have to center. You just use your raw variables with that. Okay. Yeah, it will. Yeah, it reduces the math that I'll eventually have to do with.
You said for all your predictors, it's just the moderator.
All of them. Everything on the right side of the equation gets centered for this. Okay. Now the question is, the exception is categorical indicators. Then we get into some sort of different ways you can do it. I'm going to encourage you to center to start with for your overall model, and then you play around with the coding afterwards. So for our benefits of centering, okay, it's going to give us more interpretable models, because then if I say this is the association of X on Y when everything else is hold constant at zero, I'm no longer talking about physically an actual score of zero. I mean, I am, but what does a physical score of zero represent in my centered variable, Basha? Yeah, it's just the mean, right? 0 is equal to the mean. So when I'm saying everything is held constant at 0, essentially what I'm saying is everything held constant at the mean, right? Or at the average, or so on. So it is going to facilitate interpretation. It's going to help us with the calculation of our interaction effects, make that quite a bit easier. It'll make the math simpler. And then historically, it has addressed and does address some collinearity issues associated with your interactions, because when we build our interactions, I'm going to have X and Y, and then the product of X and Y, which is going to be highly related to both X and Y because it's a component of that. When we go through and center, it cuts down on the bivariate correlations. In multivariate regression world, it doesn't do much. And so there's been a movement, mostly by Hayes. It's kind of railing against centering, but not necessarily because it's bad. It's just, I think Hayes has run into too many times when people like freak out because he didn't center, and he's like, you don't have to center. People are like, no, I learned in stat class that you have to center. Mathematically, it doesn't. I mean, it does cut down on collinearity, but actually that piece of it doesn't have any actual impact on your model, at least within OLS regression. If you sort of graduate up into some SCM stuff, then it most certainly will sort of have an impact. So general sort of take home message, always best to, or always good, I won't say best. It's good to go through and center your variables before you start sort of going into your sort of running your analysis. It's going to increase interpretability and make things a little bit easier. Like, you don't have to, like, there, you're not going to get statistics police isn't going to show up and arrest you if you don't, but you will need to do it for your moderation sets and things along those lines. We'll talk more about what's going on with this. So effects of our centering, no impact on the variability, shape of the distribution. Your standard deviation is still going to be the standard deviation. The shape of the distribution is going to be the shape of the distribution. It's going to make no impact on sort of what you're looking, which makes it different from a transform, Katie, because if I transform, then it will impact my variability. It will impact the shape. Centering doesn't. Centering would be the same thing. Here, you're just subtracting all the scores in the set from a constant by a constant. It'd be the same thing as if I added 3 to every score in the distribution. It's going to be exactly the same. It doesn't do anything to the shape or the variability of the outcome. It's going to increase the mean by 3, but outside of that, it's not going to do anything. Okay. Centering isn't going to impact the regression or correlation coefficients in models that don't contain interactive effects. What it is going to do is it's going to start to alter coefficients in models that do have interacting terms, except for those higher order terms. And when I'm talking about higher order terms, I'm talking about if I've got vectors X, Y, and Z, and X times Y, X times Z, Y times Z, and X times Y times Z. These are my first order effects or lower order effects. These are my higher order effects. So that's a 3-way interaction. We got 3 2-way interactions and then 3 main effects, right? Your centering will have an impact on all lower order effects except for your highest order effect, right? So this term will not be different than if you uncenter or did not center, but everything else sort of between there will start to change depending on this. Now, if I get rid of that 3-way interaction and just have a series of 2-way interactions, now these are my highest order effects. These are my lower order effects. These will change. This will all stay the same. Okay. This is an important thing to remember because this is a good way to go through and see if you run your models right. Because if your coefficients start jumping around for your highest order interaction terms, you know that you've made an error somewhere. Simple slopes that we'll get into, not impacted by centering. Shape of the simple slopes, not impacted by centering. So we're going to talk about how this facilitates our interpretations and why we're doing this once we get into the kind of the nuts and bolts of things. But just knowing what the impact of centering does to your models and not is a really, really nice check to make sure that you've gone through and done things correctly and that you haven't made any mistakes. these analyses, I can't emphasize this enough. This will save you so much time if you go through and sort of quality check your steps before you sort of start proceeding. And if there's something wrong, don't ignore it. Like, cripes, I got to go through, figure out what I did, because otherwise you get 7 steps down the road and then you kind of got a mess on your hands, have to start from the beginning. And it's an unfortunate side effect of applied analysis. A lot of it is, hey, I just wasted 3 hours doing this thing that's all backwards and I have to start over again. Still happens to me all the time. But just know, sort of, if we can start to put things in to fail safe, it will be the time spent on the front end will pay dividends on the time you save from having to redo stuff. So, all right, cool. Let's go through. We're making good time. Let's come back at 3:40. Okay. Questions up to this point about moderation, what we're trying to do with this stuff, with these models, at least at a conceptual level. Thank you. With any of this stuff, like if you don't understand conceptually what's going on, then you're just kind of doing things and don't understand what's happening. And then it gets really confusing and frustrating and stuff. So are we all on the same page with what we're attempting to do with these models?
So just to make sure, like the transformations of the nonlinear data, like these are for linear data?
Centering isn't a transform. Centering is just a rescaling thing. Like it basically, think about centering is the same thing as if I measure time in seconds versus minutes.
Okay.
Or if I look at height in feet versus inches, like it doesn't matter. It's not changing, you're just changing the scale of it. So transforming is a completely different thing.
Can you think of centering as like a conversion?
Yeah, it's just a conversion. It's just a conversion, right? It's a conversion so that you're still retaining the scale. You're still, the standard deviation doesn't change. You're just making it so zero is equal to mean. So if I hear 0, I just automatically think the mean. Okay. And this is what you should always be doing, even on this current assignment. Think about when you're approaching regression and any type of analysis, asking yourself, what does this literally mean? This coefficient tells me that for every unit increase in X, I would expect a corresponding unit increase in Y. And then we can start filling in what the units mean, right? For every 1 point increase in this, I would expect X to increase in Y, right? Holding everything else constant at 0. Well, what does holding everything else constant at 0? And a centered solution is holding everything constant at 0. Right, so you got your kind of your stock interpretation, and then you start sort of building things in, and it magically starts to make sense from a practical standpoint.
So then if you did a transformation, would you also center it? Like,
What's that now?
if you did like a log transformation, would you also center that?
Yeah.
Okay.
Yeah, you won't do that, and it wouldn't sort of have the only thing is make sure you wouldn't want to center something and try and log transform it, because then you got a bunch of zeros, so somewhere in the center of that goes all those things. Yeah.
So if the mean of regression is 0, then how can you have like an alternative hypothesis? That would be like your null. Probably.
We're not testing means here. We're looking at associations. Centering doesn't change the association. It's you're just sort of looking at this. So yeah, you wouldn't want to center outcomes in your 2 groups and then try and run a t-test on it. That wouldn't make any sense, because it would just be 0 and 0, right? So we're not running means-based tests here. We're just looking at association. So we're still good there. Okay. All right. So thinking about for our regression example here. Okay. So we've got if we just run our standard regression, we've got our outcome plus B naught plus B1 pain, B2 opiate use, B3 PTSD is just a straight additive model. It works out well algebraically. What we're going to do here, though, is we're going to go through and we're going to center, right? In our centered solution, PTSD and pain, we're going to center those at their respective means. So I'm going to run this, my descriptives. I'm going to find the mean of PTSD, find the mean of pain, and I'm just going to create a new variable, a new centered variable. It's just whatever the PTSD score is minus the mean for the sample, whatever the pain score is minus the mean of the sample, and I've got it all set up, right? Now we've got a dichotomous indicator here, opiate use. It's got so 0, 1. Always make sure that you're coding your dichotomous variables in regression 0 to 1. What we're going to do here is we're going to center our dichotomous variable. And remember, in this data set, we've got almost an equal split between people who are using opiates and who are not. And so if I take, if I have equal splits and I take the mean of opiate use, it's going to be 0.5. And so what I'm going to do is I'm going to take a centered opiate use variable. It's going to be opiate use minus 0.5, right? And so I'm going to people who are non-using are going to be negative 0.5, people who are using 0.5. This only happens in a balanced design. What someone will do is they'll go through and have a dichotomous predictor, and they're going to set it to 0.5 and not 0.5. That's not what we do, right? If there's 25% of the sample that has sort of our ones and not, then the mean's going to be, you know, kind of whatever 0.25, and then the low values are going to be negative 0.25, and high values are going to be 0.75, right? So this will change. What we're doing here in this base model is we're taking this, we're centering this dichotomous predictor, and what that is just doing is it's just saying we're averaging it out, right? 0 is not a real value for opiate use because no one actually has a value of 0. But what we're doing and how we're interpreting this model is we're centering it for the overall analysis, because it's just saying controlling for opiate use. Kind of going through it and sort of controlling for that and taking it out of the picture. It's different if we have it 0 and 1. Because then what it is this is the association, or this is the unique effect of X on Y when all other variables are held constant at 0. If I don't center that, then it's all other variables held constant at their mean and for people without opiate use, right? Because 0, you always want to make sure that you know what 0 means for all of your variables. But for here, we're going to go through and center the same way we did for everything else. As a result, we get the following model, okay? We've got our outcome is equal to 48.2 minus 10.71 times our centered pain value minus 0.69 times our centered opiate use value plus our sort of minus 0.23 times our centered PTSD. Okay. So what are each one of these coefficients? And what is this coefficient here? What does this tell us? What's that?
Like,
Nope, this our intercept here. Oh yeah, so B0, yes.
those are like each specific variables.
What is it? What is the interpretation of our intercept? Tell us. This is the expected value of y, right? Because it's a predicted value. This is our expected value of y when all other variables are held constant at 0. Now, if I just run an uncentered model, that's going to be a very different number, right? Because this is the expected value of y when pain, PTSD, and opiate use are all held constant at 0, which means no pain, no PTSD, and no opiate use. Here, with the centered solution, we're saying this is the expected value of y for average levels of pain and average levels of PTSD controlling for opiate use status. Right. Now all of a sudden, we're talking about a very different person in predicting functional outcomes than if it is an uncentered solution. Okay. So it starts to impact how we're thinking about things. Okay. What What about this coefficient here?
That one's just,
Uh-huh.
like that specific variable we're looking at.
Yeah, so what's the, how would we interpret this coefficient?
One is the expected value of y, and the other is 0. Expected.
Right, and can someone, can they help me out with this?
Is that the mean value of,
Not the mean value of pain. How do we interpret our regression coefficients? Not quite. So remember, these are slope coefficients. So what are,
Oh, that's like the standard feature, that's that, X for X.
yeah, that's a standardized coefficient, so but you're getting closer.
There can be a squared of, right?
What's that?
Can be a squared of B.
Roll function.
Roll function, so roll function score what, or down by 2.71.
Yeah, okay. This is saying holding opiate use and PTSD constant values of 0. This is the expected decrease in roll function per unit increase in. Josiah, what about this coefficient here?
So for every unit of, well,
You're going to keep it.
so for every unit of employed use, it's only 0.1. We expect the roll function by 1%.
Okay, cool. Now let's think about this. What does it mean to have a unit increase in opiate use? What's that?
I mean that you're using
Yeah. So controlling it means sort of going from non-use to use, right? And so if we go to non-use to use, this is the expected decrease in role functioning after we hold everything else constant, holding pain and PTSD constant at the mean. So what is this actually? What is this telling us?
that if you are there, 40 degrees, right?
This is basically a T-press. Right? I mean, it's like an and program model. We're saying like holding PTSD and pain constant to mean, we're expecting that people who are using opiates to score about 0.7 lower on role functioning relative to people who are not. This is just a group comparison. We've got a dichotomous variable here, right? And so thinking about what these coefficients are actually meaning, we can start to tease out some interesting types of things. Now we found that that's not that's not a predictor, right? We don't have evidence for that. So that's a pretty trivial amount. But we did have something that was a big difference. Like basically, this is just saying like literally the average for people who are not using or people who are using is 0.7 of a point lower than the mean of people who are using once we account for shared if we're looking at shared variability with PTSD.
So these negatives, is that suggesting that it's inverse relationship, or if there's a plus, it would have been a direct
Yep.
relationship?
Exactly. Okay. Now, Emily, you were frowning when we were talking about the intercept. Did you have a question about that?
So is that just like that y then, is that just role functioning? Like,
Yeah. I mean, because there's no coefficient, right?
okay,
Your intercept coefficient is always the expected value of outcome when everything else is held constant at 0. Because if I put 0 here, here, and here, that wipes out y equals this thing, right? This is our expected. Now, we don't often concern ourselves much with the intercept, but it is important to know what it means and how to interpret it, right? And this is going to be important because when we recognize if we, from a practical standpoint, if we're looking at our expected level of our outcome, holding all of our variables constant at the mean, we expect higher or lower levels of functioning than if these are literally 0, meaning there's nothing else there, right? It's going to be lower, right? And so when we start understanding exactly what's going on with models, start to notice things like this that make sense, that are checks to tell us that we're doing things correct.
So is the intercept like the fit of our model and like how well?
No, intercept is just telling us the elevation. It's just where do we start with stuff.
Okay.
Okay. The fit of the model, that's your R squared. That's just saying sort of how much of it or whatever we're looking at are we accounting for with this, with our best linear combination curve. And so here, this is saying for our, in this solution, we're saying for every unit increase in PTSD, we expect a corresponding 0.23 unit decrease in functioning, holding pain, controlling for opiate use, and holding pain constant at the mean. That's what's happening with these two things here. These coefficients are telling us strength of association. This is just telling us where we start when everything else is held constant at 0. So that starts to make a difference depending on what that 0 point is. Questions about this? You're going to want to make sure that for this set, so that you want to make sure that you're confident and solid on sort of your interpretations of these coefficients, kind of what's going on and how they relate. So here, if we take a look at our slides, here's our uncentered solution. Here's our centered solution. I'll have those on your screen, or you can see it up on the board. What is the difference in our coefficients between our centered solution and our uncentered solution in our model with just first order effects? Any differences? One difference. What is it?
Just the constant is different.
Yeah, the constant is different. Your intercept is different. Because again, here in this uncentered coefficient or this uncentered model, this is representing the expected value of roll function where everything is held constant at 0, which literally means no PTSD, no pain for people who aren't using opiates. Right? Start thinking about like what does it mean if I actually plug 0 into this? Versus here, our constant is telling us what's the expected value of roll functioning with pain, controlling for opiate use and holding pain and PTSD constant at the mean. Now all of a sudden we've got a much lower estimate of where people are at because we've got pain, we've got PTSD, some level of opiate use, right? And so it kind of going along in the middle. So, but aside from that, nothing else, everything else is identical. It's okay, going back to the question, is this a transform? It's not a transform. Because nothing changes. The only thing that changes is your intercept. And that makes sense because we're literally going from nothing to average, and we would expect a corresponding impact on your kind of base level.
The constant is not like the y intercept.
Yes.
Okay.
Yes.
So I'm just like trying to think of it in terms of graphically, like, I think here it's moving it, on here, the slope is staying the same, everything else is the same. It's just like,
Yeah, and we're gonna graphically present that because it's all gonna be identical. So this is kind of just showing, talking about kind of the differences between our centered and our uncentered. So in our first order models, nothing changes, and this is why I don't care really so much as if you're centering or not for this first assignment, because it doesn't really matter. It'll change your intercept, but nothing else changes. And so long as you're interpreting that intercept appropriately, I don't care, right? But what happens with these additive models, remember that what we were wanting to do with this is we want to look at the change in the relation between my predictors and my outcomes at different levels of my moderator, right? And so here, sort of reading what my question is, why we started this whole thing, I want to know what the relation of opiate use, what's the impact of opiate use on role functioning at different levels of pain and PTSD, right? And so if this is our model, right? This is our sort of mathematical representation of our prediction model here. What we can do is we can start going through and start plugging in different values for pain and PTSD. So what I'm interested in is the relation of role functioning the relation of opiate use with role functioning at different levels of pain and PTSD. Matt, if I'm interested in the effect of role functioning, what coefficient am I interested in my model here?
You're interested in PTSD, isn't it just the PTSD one?
What I'm really interested in is the impact or the association of opiate use with role functioning, my outcome at different levels of pain and PTSD. So which coefficient am I interested in looking at here? Opiate use, 0.69, right? So let's say I go through, here's my model, right? And what I want to do is I want to say, look at high pain and high PTSD. So in my centered variables, this is also a nice thing. If I want to look at a standard deviation above and below, and I've centered everything, now high pain is 1.34, low pain is negative 1.34, high PTSD 19.76, negative 19.76, right? This is where it's making my math easier. I just take my standard deviation plus or minus, right? So what I want to do is I want to look at the impact of opiate use on role functioning at both high pain and high PTSD. So high pain corresponds to a score 1.34, high PTSD 19.76. I go through and plug those into my equation. And I go through and I sort of do the math, sort of adding things and sort of consolidating terms and things like that. And I find that opiate use at high pain and high PTSD, my effective opiate use on role functioning is negative 0.69. Right? So again, from people going from no use to use, I'm expecting a 0.69 unit decrease in role functioning across those two groups. What happens then if I want to say, okay, well, what about, and then if I were to plug in values for centered opiate use, negative 0.5 and 5, I get sort of my expected value of role functioning for no opiate use, 29.65, opiate use 28.696. If I subtract those two, I get 0.69. Everything kind of turns out nicely because that's how math works, right? But let's say, what about low pain or low pain and high PTSD? What happens to the association of opiate use if I plug in values for low pain and high PTSD? So again, I go back to my model, but this time I plug in low pain. Low pain in my centered variable is negative 1.34. At least if we're identifying or operationalizing low pain as a standard deviation below. So I plug 1.34 into there. High PTSD is still 19.76. Drop that in there. Go through, run my math. What happened to the relation between opiate use and role functioning? Nothing. It's the same. And if I go through and plug in values, negative 0.5 and 0.5 for opiate use, again, this is only because this is a balanced sort of variable. It sort of high and low levels won't always be 0.5 and negative 0.5. It just happened to be here. Okay. So I get these, and the difference between these two is just negative 0.6 or 0.69. What if I'm sort of interested? Let's say, okay, well, that didn't work. What if I want to look at the relation of PTSD with functioning at different levels of pain and opiate use? Okay, so I'm still using my same model, right? I go low pain and opiate use. Low pain, negative 1.34. Opiate use is 0.5 in my data set. I'm getting negative 0.23, which is exactly what I had before, right? I want to go high pain and opiate use, same thing, right? Doesn't matter what values of these other variables I'm putting in. Does any of this ever change the nature of the relation between X and Y? No, it doesn't, because it can't, because this is what's going on in the additive model. When we're describing, when we're interpreting, anytime you see a regression model and you look at an effect, right? That effect is always going to be the expected change in Y, given a unit change in X, holding everything else constant at 0. Like if you tattoo that phrase on your body and just give that for any interpretation of any regression coefficient forever and always, you will be correct. And if you start plugging in variables and what those actually mean and sort of things, like you will always be correct, right? But for our additive models, it really doesn't matter because there's with these just straight first order models, once we go through and estimate those coefficients, they're going to be the same. It doesn't matter if I have it doesn't matter if I hold PTSD equal to the mean or the max or any other such thing. It's never going to change any of the other coefficients. So in this model, the way I have it set up, can I look at the extent to which pain changes the nature of the relation between these? I look at and sort of determine the extent to which opiate use impacts the association between pain and function. Can't do it mathematically, it's not, it's gonna be constant all the time. If I go through and I look at your graphs, it doesn't matter. If I'm interested in looking at if X is PTSD and Y is functioning, here's low painted opiate use, high painted opiate use. I can throw in any combination that I want to. So this part of it changes, but the slope never changes. It's always the same. We'll see mathematically how this is coming together and why this isn't working or getting at what we want it to get at. So what we need to do then, in order to ask the questions that we want to ask, we have to start including interaction terms, right? We have to upgrade the multiplicative model here. And as soon as we start throwing in these interactions, now this gives us an opportunity to look at how different levels of one variable can start to change the nature of the relation with another. So here, again, just to remind us, our question is, do opiate medications influence the impact of physical pain on oral functioning and survivors of serious accidents, right? Does pain change the nature of the relation between PTSD and functioning following motor vehicle trauma? Okay? These are moderation questions that we can't test in just a straight baseline sort of first order model. Okay? So what we're going to do is we're going to keep that first order model, but then we're going to start throwing in interaction terms that starts getting at our questions here. Okay? So here I've got my intercept, I've got my effective pain, my effective opiate use, my effective PTSD, but now I've got an interaction term that's the interaction of opiate use and pain, right? That's getting at my first hypothesis here. And then I've modeled something to test my second question, pain and PTSD. This is getting at my second question here. Okay. What I'm doing is I've built into this model specific terms that are going to test these hypotheses or these questions that I have. Now, there are other interactions. I could have opiate use and PTSD, and I could have opiate use and PTSD, and I have three-way interaction, right? But there's nothing that says that you have to have a fully factorial model in here. Probably there are generally probably not going to want to do that unless you have a specific reason for going through that.
I'm sorry, but can you explain the difference between, like, this makes sense to me, like how that's moderation, like, because it's opioid times pain and stuff, but the model that we just looked at, what was that looking at if it wasn't looking at like moderation?
Yeah, what was that looking at? What's that first order model? What questions can I ask with that first order model? And you're right. So what questions are we asking with that? Just that straight standard regression. Okay, there you go. I can look at the unit correlation. I can say if I hold constant, if I sort of control for these other variables, what's the association of X and Y, right? Which will tell me sort of the unique association there. But if we have a situation where X and Y do hold an interaction, the problem is that what we've done is we've misspecified that model, missing a component. I mean, we'll run the model, but there's nothing in the model that will tell us that we've misspecified it, right? But if there is a moderating effect of X and Y and we didn't include it, we've kind of got a biased model, right? We're missing an important component or a part of this phenomenology that we haven't modeled appropriately, and the model's not going to tell us that, right? This has to be a conceptual question that you think about. I wonder if the nature of X, of the relation between X and Y changes depending on where Y is. Based on what I know about this, it seems as though for people who have high levels of this, I might expect a stronger association relative to people with low levels of this. I wonder if I then need to go through and create a interaction. So essentially what we've done is we've committed a violation of our basic regression assumption. We have a misspecified model, right? So these are all, but there's no statistical way to test that outside of just
the running model with an interaction, see what it turns out, you know. So this is also falls back on that conceptual knowledge and understanding your area and thinking about like, would it make sense? Would I have reason to expect this thing to change the nature of the relation to something else? So you think about, you often hear about your standard regression models. You hear about these talked about is just this kind of horse race, right? You just kind of throw things in there and see, you know, like Thunderdome style, like which one of these things continues to sort of hold up and predict after we control for other things, right? That's just saying, just a straight main effect of sort of this controlling for other things, right? And so what kind of fully unique relation, like unique association with my outcome, but I can't touch moderation.
So it's the direct effects, and then is like the moderation and indirect effects.
Not indirect effects. That's a different thing that's going to get into some mediation types of things. Talking about here in the presence of significant interaction, we no longer have main effects. What do we have? Interaction. An interaction, but in the presence of an interaction, we have conditional effects, right? Conditional in that this is the association between X and Y that changes depending on sort of some other third variable. Okay. So with these new additional terms that we've included in here, my opiate by pain interaction test the hypothesis that the relation of pain and functioning depends on opiate use. Okay. It's going to say, does whether or not people are taking opiate medications or not, does that sort of change how pain severity is related to functioning, right? Or pain times PTSD. This is testing the hypothesis that the impact of PTSD on functioning differs based on pain severity, right? Like, so Elizabeth, if you come in and say, hey, Josh, you should work with people in trauma and you've done car accident stuff, how does pain or PTSD impact functioning? Because I've got a client who has PTSD. And I say, well, I don't know. If I have evidence that the pain has an impact, like, well, how much pain do they have? How we see in this model is that if I have high levels of pain, it doesn't matter. Because I can hurt, you know, I'm in pain all the time and my function is poured out. And so I have high levels of PTSD or low levels, it doesn't matter at all. My pain is so high, it's flooding everything out. In that situation, I would say maybe work on pain management stuff. And secondary because you can screw around. The functional outcomes aren't going to change because you got so high level of pain, right? So this is the types of consideration when we're thinking about practical impact, theoretical impact, why some of this stuff starts to come important. So, as always, remember that our interactions are symmetrical, right? I've set this up from a conceptual standpoint to talk about the impact of opiate use on the association between pain and functioning. But I could just, there's no reason I couldn't talk about this as the impact of pain on the relation between opiate use and functioning. Same thing, talking about this is the impact of pain on the relation between PTSD and functioning. Talking about PTSD is the impact of pain and functioning. There's going to be, this is largely a conceptual thing, but empirically it starts, if X holds no association with Y, if the moderator does, then that starts to become like, so they're talking about the impact of my moderator on the relation between X and Y, when X and Y doesn't hold a relation with one another. So there's going to be some things you want to take a look at in terms of thinking about how we go through and talk about different effects, but mathematically they're interchangeable.
So with that, can you even do a moderation if X and Y aren't related? Or,
Yep. Is what we do. What am I fine? This doesn't necessarily make sense. This is pain functioning and You know? Okay, so for opiate use. Here. That's what that looks like. Where's my main effect? Controlling for opiate use, where's that gonna land in my overall regression model? Yeah, it's just gonna bisect this. And so in my overall model, it's gonna look like pain doesn't have a relation to function. Right? And what I can get here, remember, just as with our animal models, you don't have to have a direct effect in order to have an interaction. Right? And this is our classic cross effect, right? That could say that, and this is where that model specification starts to become really, really important. Because if I just run this model without the interaction, what's my conclusion? That the pain's unrelated to functioning, right? That's not the case at all. It's just pain is moderated by a third variable, right? And when we have that in there, we see a very strong association with one, and negative association with the other. The bisection of that is sort of nothing at all. And so what we could do is potentially we would miss if we did not, if this is what was going on in our data and we didn't model that interaction, we would miss that completely. We would misrepresent the nature of the relation between pain and PTSD. We would misspecify our model, or pain and function. We would misspecify our model. Okay. So always important to think about sort of what's going on in our data, so that and think carefully about our interpretations.
Post-hoc test then?
We'll get to that.
Okay. Like, I don't know, it's gonna like see if you interact. Expression, are we gonna need to like?
Yes. Yes. I think I know what you're saying. Hold on to that. Let me get a couple slides in and then so we can revisit. All right. Other questions with this? Okay, so let's start with some baby steps here. And let's sort of reduce this down to sort of say what we want to know is whether or not opiate use influences the relation between pain and function. Okay, so we're just going to break this down into a two-variable model where we've got functioning. We're looking at opiate use and pain, and then our interaction terms. That interaction term is going to test our moderation hypothesis. Okay, so we go through and we run this, and this is the output we get. We see y equals 10.04, coefficient for opiate use, coefficient for pain, and then we have our coefficient for our interaction term. Now, when we run this in SPSS, we're going to get p-value for each one of these. It's going to tell us whether or not we have evidence for an effect or not. So, Sam, I have to create this in my data set and sort of enter it as a variable. But then once I do that, SPSS just tests it as the interaction, just like we would in ANOVA, and then say, yes, I have evidence for an interactive effect of pain and opiate use on role functioning. And then we need to follow up with that in terms of simple slopes, which is like our post-hoc test. Okay. So, what we're going to do is start to do a little bit of math here, okay, is what we need to do is start to restructure this equation in order to start plotting things out, okay? So what I can do is if I start using properties of algebra and thinking about how we go through and factor things out, I can start to restructure this equation, because what I'm interested, I'm going to, show of hands, anybody like up to speed on their algebra? Emily? No one else?
I don't know how does. This is like the one thing I know.
Okay. So what I'm going to do is I'm going to walk through kind of like steps. So forgive me, this isn't sort of proper math class, but for people who maybe is shaky on algebra because they took it in sort of 8th grade, sort of thinking about how to go through approaches. So here's my equation, right? And I'm interested in looking at whether or not opiate use influences the relation between pain and functioning. Okay, if this is my, I've got this set up, Elizabeth. What is my moderator in this question? What's my moderator and what's my conditional effect? What's the association I'm interested in, and then what's the moderator?
So
Okay,
non-reimbursable.
perfect, okay. When I'm gonna go through and I'm gonna start factoring this out, what I'm gonna do is I'm gonna drop down any terms that don't involve my conditional effect. Okay. Amanda, what's my conditional effect? Pain, okay. Pain is my conditional effect. So I'm gonna go down and I'm gonna drop out, I'm gonna bring down everything that doesn't include my conditional effect, which is pain, okay? So I drop down, I've got 10.04 minus 0.68 volts. Okay. Then what I'm gonna do is I'm gonna go through and I'm gonna drop down and sort of bracket off and have my conditional effect there. And here my conditional effect is pain. Okay. Then what I'm gonna do is now I'm gonna have to use a little bit of algebra to go through and sort of deconstruct this, right? So what I've got, if I factor pain out of this and bring this down, I've got negative 10.05 plus 0.460 opiates left over. And I've got pain left over. So I factored this out. If I go back through, this is going to be the bane of your existence. You're going to screw this up, okay? Check on this is if I go through and I re-multiply this out, if this is where you get with your factored equation, you re-multiply it out, you get back to here, right? So if I take this and I take pain times negative 10.05 and pain times this, I end up with negative 10.5 pain, 4.60 pain times OPUs, yeah, so I get back to here. Okay. And then what I do is I've got this restructured equation. This is mathematically equivalent to this, but I've restructured it to sort of be specifically looking at what's going into this impacted pain here. And so now, if I go through and I want to say, I want to look at the relation of pain with my outcome, right? Pain and role functioning for people with no opiates, right? So I take my restructured equation here, and for whenever there's opiate use, I know that no opiate use is negative 0.5, so I drop in 0.5. For opiate use, 0.5 for opiate use, right? And then I go through and I run that math out. I get an effective negative 12.35, right? Amanda, what does that negative 12.35? Can you give me an interpretation of that coefficient?
Constant is the,
Per expected change in outcome for every unit increase in. Okay. And so this is then saying what? 12.35, and again, this is where I sort of start plugging the words in so that it all kind of falls together. I'm expecting a 12.35 unit decrease in role function per every unit increase in pain when I'm talking about people who are not using opiates. Don't do that. No. The predicted outcome is the predicted outcome. Because our regression model is accounting for a correlation between our predictors. We can't do it the other way. We're always predicting our outcome, right? So you could say that for
Like it's always gonna be in terms of role function.
yes,
You could say it's for increasing role function, for decreasing pain, or decreasing role function for pain. Okay.
you wouldn't say sort of an expected change, like a unit change in role function is associated. Then that's a different perception. That's backwards. That's not the model. Okay, so this is what we've got, and this is representing the unique effect of pain with role functioning for who? People not using opiates. Okay, but now let's see what happens if we go through and plug in for people who are using opiates. That's 0.5, right? Now we go through and instead of negative 0.5, we drop in 0.5 for opiate use, 0.5 for opiate use, and we run that math out. Now what do we get to that?
So for every 7.75 Or sorry, for every increase in pain, will function.
Okay, yeah, so you can say it that way. I would probably still say for every unit increase in pain, we get a 7.75 unit decrease in roll function. But yeah, technically what you said is fine, just playing around with the things, all right? Now, all of a sudden, before with our first order effect model, when we start plugging in different values to change our slope. Nope. But now it does, right? And what we can go through and see with this is that with the way once here, it's hard to see, but once we restructure this equation, this coefficient for pain is dependent on opiate use. What value you plug in for opiate use is going to change what this number is, right? So what this restructuring is going to do is it's going to allow you to plot out your simple slopes, but it's also very clearly you're saying, okay, this coefficient of pain, the unique effect of pain on my outcome, depends on what value I put in there. If I put in different values, it's going to change the nature of that relation, which is the heart and soul of moderation.
I think that's elsewhere. Isolate the variable Y's, get pain or.
No, we don't care. We're just predicting why big Y's are out. We're not solving for anything.
Okay, that's where I'm
We're
like, that's
just-
what
we're
my
just-
brain's
We're solving for Y, but we've got all the numbers we need.
got it. Okay.
All right. So let's say we want to switch things over and so look at our full model, right? Remember that we're interested in the impact of pain severity on the relation between PTSD and role functioning, and the impact of opiate medications on the relation between pain and role functioning. So again, if we go through and take a look at our model with opiate use, pain, PTSD, and our two interaction terms. Right. We're looking at PTSD and functioning, and we're thinking conceptually about pain as our moderator, pain and functioning, opiate use moderator. Okay. So again, what we need to do is we're going through, now this is a more complicated equation to restructure, right? Because we've got multiple terms. First thing I want to do is say I want to move down everything that doesn't include a first order effect, or excuse me, a conditional effect. I have what are my conditional effects in this, Basha? For the variables associated with my conditional effects. It's going to be PTSD, right, and my pain, right. So those are the two things those are the two variables that are going to be still my conditional effect. Pain and opiate use, these are going to be my moderators. So what I'm going to do is I'm going to drop down first my intercept here, then my opiate use, because that's not, opiate use is in a conditional effect, right? It's a moderator, but it's not a conditional effect. And I'm going to sort of pull down my two conditional effects. I've got pain and PTSD, these are my conditional effects. Okay. Bracket those off. Then what I'm going to do is I'm going to start with pain, okay? So I've got here pain and here pain, right, that are involved in this first sort of thing. So I've dropped down negative 10.5 plus 4.6 times pain. Now we've got pain here, but pain's associated, that's sort of linked to a different conditional effect. So we're going to leave that alone. Then we're going to drop down here, bring these ones down. We've got PTSD. PTSD, we're going to drop this down, and this is going to give me my restructured equation. Now, if I go backwards, again, this is more complicated, but if I go through you will always want to do this. Make sure that you've got it right because it will often not go correctly. So if I'm looking at that, I'm saying, okay, so I've got y equals 10.04 plus 0.86 opiate use. Okay, so then I'm going to run that out, which is going to give me negative 10.05 pain plus 4.60 opiate times pain. Run the second one out. Give me negative 0.19 PTSD, negative 0.17 pain times PTSD. I end up back up where I started. Yeah. Was it? Oh, whoops, yep, thank you. Check on that. This stuff will happen, so to go through and make sure, because that will mess with stuff, so, okay. Signs will also be the bane of your existence with this, so always when you're dropping things down, plus bracket, sort of conditional effect, plus bracket conditional effect, and then just make sure that you're running your stuff out. Okay, so if you do this correctly, when you get your restructured equation, you should be able to go back through and get sort of your original model. Yeah.
So, moderators versus conditional on some sort, I thought before you said that they could be interchangeable.
They are.
So then, is the second one in that multiplication that is the conditional versus the moderator? Because like I'm confused as to why opioid use is a moderator but not a conditional effect.
Because I'm not, so in my question, the way I've set this up, I'm not asking about the sort of the impact of something on the relation between both people. I could restructure it that way, but then that changes how I go through and take a look. What you're trying to do with this is you're trying to break this down so that you've isolated your conditional effects here, right? And your conditional effects end up being a function of, here you can say the relation of PTSD with functioning is dependent on pain. What value I put in for pain here is going to change this coefficient, right? If it's a higher value, it's going to be stronger. If it's a negative value, it's going to be lower, right? So when we look at this, by definition, the level of pain changes the nature of the relation between PTSD and functional. Same thing here. Opiate use, by definition, is going to change the nature of the relation between pain and functioning. Depending on what value I put in here, this term, that number is going to start changing around, right? And so what we do when we start doing this is that so you can see from an equation standpoint that the coefficient for PTSD is dependent on pain. The coefficient for pain is dependent on opiate use. Now we can go through and switch this around. And I could ask, and I could say, I could restructure this so I'm looking at the impact of the extent to which pain severity impacts the relation between opiate use and outcome, but then I can sort of change the way how I restructure it. It'll still end up with an equivalent model, but it'll look different. Okay. And so this starts to become important in setting up for some slopes.
So I think I get this, because like, you want to look at PTSD, but PTSD depends on pain, but pain depends on opiate use, and opiate use depends on anything that's like that.
Yep.
Got it. Okay, I see it
And
now.
we're going to get there in just a moment. Yeah.
And I have two questions.
Yeah.
My first one is, do we always do this by hand or can we do this on SPSS?
You will need to do this by hand.
Okay.
Yeah.
And then my second question is, can you look at interaction effects concurrent? You have two or more, or
Yep. And that's what we're going to do. That's what we're going to do here.
okay.
So here within this, what I might find is that I could find, I might find that I have evidence for both of these interactions coming up, which is saying simultaneously that the relation of pain on functioning depends on opiate use, or opiate use on pain, on functioning depends on pain. The effect of PTSD on functioning depends on pain. The effect of pain on PTSD depends on functioning. This starts to become where you need to have a good sense for conceptually, how am I thinking about this? A priori, I should come in. And generally what happens is, again, we've got in the literature, a really good literature that says X is related to Y. X is always kind of related to Y. What are the boundaries? Like, what are the things that might change the nature of the relation between X and Y? Okay. That's generally the strongest way to treat it come in. Not always. Sometimes, again, what you find is, and if we were to reverse this and look at sort of the relation of PTSD or sort of the relation of the impact with this one, let's say if we looked at the impact of PTSD on the relation between pain and outcome, it might not change, but if we look at it the other way, that's where that interaction is happening. So the same thing with your ANOVA models, right? Like you can change on sort of how you formulate your comparisons, which is going to start to sort of impact how you're thinking about stuff. But with this, it's all should be driven conceptually. Hopefully, you're thinking about this before you jump in.
Wait, Steve, do you have another question?
No.
Okay. So people are not really get into, right? So we've been talking about this in terms of like how modern what the very hard. But then so in terms of interpretation, are people who are using opiates versus not. So when we get into modern opiates, is it like for people hiring this not, or do you start to get into like as this increases?
These are all excellent questions that we're going to get into because that's kind of the traditional way is to pick a high level of PT or your moderator and a low level of your moderator, which generally corresponds to a standard deviation above and below. But that's completely arbitrary. It's conventional. And as you start to get higher and higher levels, your moderator, your graphs will get more extreme. Like I don't know what's the relation between X and Y at 5 standard deviations above and below. It's kind of a ridiculous question because have anybody scoring 5 standard deviations above or below, right? At least you can sort of inflate that. But there are different ways that we won't get into in depth here. We will touch on that looks at sort of more continuous impact of moderator on your outcome. That provides a lot more information. Blocks, yeah.
We don't have a lot enough variability in our moderator. Things are probably getting pretty.
Yeah.
Underlying assumptions.
Anytime you don't have anytime you don't have variability in your predictors, things are going to get screwy. So, yeah. Okay, so from our restructured equation here, see that the effect of pain is now conditioned or dependent on opiate use. Depending on what value you plug in here, this value is going to change, right? And the effect of PTSD is now conditioned on pain, right? The value of pain that we put on is going to start to change the nature of this coefficient. The question is does it change it to a degree that looks to be meaningful or statistically relevant, right? And that may not be the case, but by definition, if we've included an interaction term in there, even if that interaction don't have evidence for that interaction, it's still by definition going to change this at least a little bit in terms of what value go on here, okay? And so in this situation, particularly if we have evidence for these interactions, what's going to happen is we're going to talk about pain and PTSD here. These pain and PTSD, these coefficients as conditional effects, right? These coefficients right here represent the association of PTSD and pain when everything else in the model is held equal to 0. If we start changing those around, then that starts to change up. Right. So this is where we get into our simple slopes. Right. What we're going to do by convention, if we're looking at our simple slopes, we're looking at for our continuous, well, yeah. So we're going to start with our continuous variable. So we're looking at the relation of pain impacting the association of PTSD and role functioning, right? Now, pain is a continuous variable. What do we choose as high and low values? Convention says it's a standard deviation above or below. And that's just because a standard deviation is a standard deviation. It's a sort of concept that people are generally familiar with, right? And so what we're going to do then, once we've restructured our equation, is we're going to substitute high and low values of pain, holding everything else constant at the mean, okay? So for high pain, here's our restructured equation, right? This is just this, once we go through and run this out, right? And we have high pain is a standard deviation above 1.34, low pain negative 1.34. And so what we want to look at is the relation of PTSD and functioning at high levels of pain. We take 1.34, plug this in for pain, plug this in for pain, holding everything else constant at 0, right? Well, here we've got opiate use that drops out. This opiate use, that's 0, so that drops out. And so what we're left with is our intercept minus 10.05 pain plus pain minus PTSD. We go through, we multiply by 1.34, drop that in. What we get is our simple slopes equation, which is going to be our expected value for outcome. It's going to be negative 3.43 plus 0.04 PTSD. Okay, and this now is the simple slope of PTSD condition on high pain severity. If we go through and want to look at low pain, you're going to start with the same equation here, except we're going to start from right here. We're going to sort of cancel out the same thing, and we're just plugging zeros into stuff, right? Plugging 0 into here, so we get back to this. Now we're going to put in low levels of pain, negative 1.34. So to work that in, and what we end up is our conditional effect of PTSD on role functioning at low levels of pain. With these models, if you're starting to get confused, again, think about like, sure, what this stuff is. Holding things constant at 0. Well, holding everything constant at 0, not pain, because pain is my conditional effect, and PTSD is PTSD is my conditional effect. Pain is my moderator. If I plug zeros in for everything else, terms start dropping out of that, right? Because I'm multiplying things by 0 and they just go away, which is nice. Another nice reason for centering is I'm holding things constant at the mean. Multiplying things by 0 makes things easy because things start just going away, right? But if I go through and then start plugging in values, what I see is I get a very different relation of PTSD with my outcome at high levels of pain versus low levels of pain. Yeah.
Two quick questions. So the reason why the opioids drop out is because we're saying that those are 0, right? So we're putting in 0 for that. If we hadn't censored, then would we have to put in like a value, like whatever value that was done?
Well, what we would be doing then is changes the nature of the question, right? Because if we did that, then we're saying, what's the nature of PTSD with functioning for people who are not using opiates? What does 0 mean in a for opiate use in our uncensored model? What's that? But in our uncensored model, what does 0 represent?
Oh.
Yeah, so people who don't use opiates, right? And so this is important. Why is always, I can't say this enough. Thinking about what does 0 mean conceptually? Who is 0 capturing, right? Because with any of these models, if you say this is the relation of X and Y holding everything else constant at 0, sometimes holding things constant at 0 means the absence of stuff. Sometimes it means like a value that's not original. Sometimes it means people who are in this category, the reference category. So it always starts to become important to start thinking about what that means.
So how do I hold anything with 0 and just absent? If here is higher than the mean and we're holding it 0 and holding it.
Yeah, just holding it constant. The mean of opiate use doesn't really make a lot of sense. You can think about it that way, but we're just holding it constant. We're taking it out. We're taking sort of this piece that was attributable to opiate use, we're pulling it out and setting it on the side, so we're not worried about it. Okay? But if I didn't, then specifically I'm looking at people who are not using opiates. Okay? That's where it starts to become important. So we're knowing what those 0 values are.
So because it's looking at just in relation with the why we're putting in a variable to pain so that it's not looking to solve it. We're simply solve it.
So that's what I'm trying to look at is how does make sure the relation of PTSD and outcome change as I'm starting to sort through, put through other values of pain, holding everything else constant at 0. Holding everything else constant at 0, I mean that there's holding it to mean or just holding it constant. I can't tell you how many sort of games I've got myself out of like with these complex things, just sitting down and okay, what does 0 mean? 0 means that this person is there, or so this means this reference group or this, and then just kind of literally like working through this stuff. Like this is like the template. The template is always the same. You just start putting and plugging in sort of what those values mean, and then all of a sudden things start to like, oh, okay, I see how this works out. All right, so this is solving the simple slopes for our pain. But now we want to go back to talk about our simple slopes for our opiate use. Here, what we're going to do is we're going to enter values corresponding to opiate use and non-opiate use, holding everything else constant at the mean, right? To look at the moderating effects of opiate use on the relation between pain and function. So now remember here, because we centered opiate use, 0 doesn't really mean anything. It just becomes holding it constant. Now, if we look at our data, people who aren't using opiates are -0.5. People who are using opiates are 0.5, or -0.5. People who are using opiates 0.5.
And it's only 0.5 and -0.5 because they're
Yes.
exactly.
Yes. Yes. This will not always happen, right? Do not think that just when you get to this point for dichotomous variable, I have a -0.5 and 0.5 because it's a dichotomous variable. Go through and look at your data. For people who are using, what's the number? People who are using, what's the number? That's the number. So here, what we're going to do, we're going to do the same thing. So here's our restructured equation that we had from 2 slides ago. We'll go through, put things together. What we're going to do is we're going to go through and start putting 0 in for everything that we're not interested in. Here it's opiate use and pain, right? So we put in 0 for PTSD. That all goes away. And so we're left with this piece of things. Now what I'm going to do for no opiate use, I'm going to start plugging in -0.5 for opiate use, right? So I plug in -0.5 here, -0.5 here. And what this ends up is giving me my simple slope of the association or the effect of pain on functioning for people who aren't using opiates. Then I go back up. I want to do the same thing for opiate use. Start back here. I know that's going to cancel out. Drop in 0.5. Now I have my simple slope for pain severity on role functioning for people who are using opiates.
So when you're centering things, you're essentially just like freezing the rest of things that you're not interested in because you want to ensure that like any changes in the nature of a relationship is responsible only for the interaction effect that you're interested in and not like other variables.
It simplifies the math. Again, I don't have to, right? And so this is getting what you said, do we need to, do I need to know how to sort of restructure equations and things like that? For this class, you will. Like you would definitely will. So definitely make sure that you know how to do that. But this is why sort of macro like process has become popular, because it eliminates all this stuff that you kind of have to do to make sure things are running. And so long as you enter the model correctly, it's just going to give you outcomes in that because it's all part of the computer. So it doesn't really matter if you center things or not. It's just kind of going through. But it kind of does matter because there's going to be some thinking about who am I talking about? Who is this regression predicting things for? And did I do things right? And this is why sort of understanding how these coefficients work in this model starts to become important because like there's just a lot of things that can go wrong in this. There are always checks to make sure that things are working right, that you've done things correctly. But if you don't understand this is why things start to fall away. I can run this model without centering, but it just makes the math a lot more complicated. I can do it, right? I just have to keep track of what's high levels, right? So if I didn't, let's say I didn't center, right? And so now my mean level of pain is 3.5 and my standard deviation is 2.76. And so now I have to say, okay, what's 3.5 plus 2.76? And now I have to plug that in. And now I'm sort of looking at this. This is the simple slope relation between x and y when sort of pain is equal to 0. The 0 is not actually a real value on the scale. So that starts to screw with interpretations, right? So this is why all this stuff kind of comes together. This is why historically this has been kind of difficult for people to do. Now it's easier, so we've got things that will just automatically do it for you. But the problem is I sort of feel a lot of people where people are like, I've done this, but if you look at it, it's like none of that makes sense, right? So thinking about knowing how to use our tools and sort of understanding some of the background. And this is why if your PACE centering isn't such a big deal because you got a macro that just goes through and calculates things appropriately for you so long as you enter them correctly. But if we're doing it sort of the traditional sort of approach, then it starts to become easier to do some of this stuff. And then positive benefits for interpretation. So what we've done here is we've gone through and looked at simple slopes for the conditional effect of PTSD and the conditional effect for pain. Now, holding PTSD constant, the mean here is okay as long as they're not a three-way interaction. This is going back to if there is a three-way interaction, then we miss important things, and now we have a misspecified model, and so wanting to think carefully about that now. Talk about this as you start to get three-way interactions and God help us four-way interactions and things like that. It just really starts to become hard to keep those out. So if you have a good reason to improve three-way interactions, certainly do it. It's plausible. Do that, right? But you're generally not going to do that. Doesn't mean you can't test them, but it starts to become hard to identify some of those. All right, so here's what we end up doing. What we end up, yeah.
All right, I'm just gonna ask for like fluid, like, how do you visualize those? Like, is the other variables in the air?
Panels. So
Oh, just two panels.
two panels. Yeah.
They're independent.
Yeah, that's for this group. Here's what the conditional effect of PTSD on function looks like at high and low levels of pain for this group. Here's but for non-opiate users, if you have three interactions, the conditional effect of PTSD on functioning at high and low levels of pain for people who are using this conditional effect of PTSD on neural functioning at high and low levels of pain or using. So visualizing it that way starts to become scary.
Higher level.
Yep. Yep. Yep.
Also, like a post-hoc thing though, where it's like you won't know if there's like a three-way interaction and then.
Yeah, there's nothing in the model that's going to say, hey, you're missing a three-way interaction, right? Like you would need to go through and test for it. But again, that should be guided more by theory than just doing it to do it. So if we go through and we plot our simple slopes here, okay? Here's our simple slope for our simple slope effect for opiate use and pain, right? Here's my equation for no use, high pain, low pain. What we just do in Excel, we just go through and just plot this out. And we see, Matt, I haven't picked on you for a while. If we're saying that we found in our sort of main model, we've got an interaction of, we do have evidence for an interaction of opiate use and pain. What's going on in this first panel here? What is the impact of opiate use on this association of pain and functioning?
Can you repeat the question?
What's that?
Can you repeat the question?
Yeah, so if I'm looking at the association of pain and functioning, what's the impact of opiate use on the effect of pain and functioning? Here, this is kind of a unique thing. Think about sort of, we're always looking at strength of associations.
Honestly, I have no idea what to say or what I'm looking at. The lines cross one another. I don't know.
Okay, so the line is crossed.
So if you have low pain, do you decrease functioning compared to no?
So what you're doing right there makes perfect sense in terms of why you look at that. But remember, sort of going back to the very start of class, remember that we're talking about what happens when Samus goes to the you were asking, is there ever a point where we want to sort of compare these two lines? Probably not, because these are just arbitrary points at high and low. If we brought it farther out, they would be more or further apart. These aren't actually observed values necessarily. These are just point estimates for this line at this point in time. What we would do, because this is a regression model with continuous outcomes, I would say here, and we can see it if we're looking at these coefficients. So we would say that for individual, there appears to be a stronger association, a stronger negative association between pain and functioning for individuals who are not taking opiates as opposed to those who are. That slope is indicating magnitude of association, right? And so we're saying for people who are taking medications, there's a weaker association between pain and functioning for people who are taking meds as opposed to those who aren't. For people who aren't taking medications, we're seeing a stronger association, a negative association between pain and role functioning. As pain increases, it's much more tightly connected to role, or not much more, at least somewhat more associated with reductions in functioning. For people who are taking meds, less so. Which overall is kind of evidence for what we would hope is going on with medications. It's saying that, yeah, people were taking these opiate medications, these pain medications, are kind of decoupling the relation between pain and functioning. Not 100%, right? But at least to a little bit. So I could interpret that as evidence for functional utility of opiate medications here. Same thing here. If I look at this graph here, right? What I'm looking at is I'm not looking at differences, right? Because these aren't real points, right? And these are just points that I happen to pick out. They could be anything at all, right? What I'm saying here is we're saying that PTSD has a negative association with functioning for people with low levels of pain. But for people with high levels of pain, PTSD doesn't hold any effect on role functioning for people with high levels of pain. It also makes some sense, right? If I'm not, if I don't have any pain, if I'm sort of physically feeling okay, yeah, my PTSD increases, my functioning decreases. If I'm slammed, my pain's at a 10 all the time and I can't move without being in intense physical pain, who cares about my PTSD? Like, it doesn't matter. My functioning is just forward out. Right? So again, thinking about this, and again, everybody look at me in the eyes. Resist the urge to say levels of anything, right? Unless we're talking about levels of our moderator. What you'll want to do is start interpreting these as evidence of mean differences. That's not what we're looking at. We're looking at strength of association. Here, opiate use is impacting the strength of the association between pain and functioning, in that we have a stronger association between pain and functioning for people who are taking or not taking opiates versus those who are. Here, we've got a stronger association between PTSD and functioning for people who are at low levels of pain, as opposed to high levels of pain, with low and high determined by standard deviation above and below.
Moderator in that instance, that's why we can say levels. Okay.
Yeah.
Okay.
Yeah. And again, this is kind of an arbitrary thing where we say high and low. You'll see here we've got for high and low levels of pain, it's always just a standard deviation above and below, and this just kind of ends up being helpful for what's sort of standard in the field. So I want to respect your time. We're past time. If you need to take off, do that, but I will continue here to sort of answer questions for people who have them. So,
I would just wonder if this might be a little bit, but if we know that pain will be used moderate to between pain and functioning, and that pain moderate the functioning or PTSD level. Would that kind of beg the question that opiate use might, that there might be something like that?
yeah, you could. That would be a reasonable question to ask based on what we have here, right? And you, as if I was trying to submit this as a paper, you as a reviewer would be reasonable to. So did you test the three-way interaction? Like, I wonder if there's anything going on there. Yep, your head's in exactly the right place. Anybody else have a question? Pain PTSD one? Yeah. So what we're saying is for if we're holding pain constant at a standard deviation of right, what we're seeing is that there is a negative relation between PTSD and function. But at high levels of pain, so the standard deviation above the mean pain, we're seeing no association here with PTSD and function.
area of relation to the gap.
Yep.
I think kind of straight.
Yeah. Now, this is the thing, we'll get into this, we see it's a little bit of an uptick, right? The question then becomes, do we have evidence? Like, is this positive? Is this uptick, right? Do we have evidence that sort of maybe at high levels of pain, PTSD is associated with increased functioning? That's where we can't tell this. We can't tell this from our simple slopes graph. What we need to do is go back through, and this is what we'll start with next week. We need to hijack SPSS and start screwing around with recentering our variables to go through and test the significance of this slope, this slope, this slope, and this slope, so that we can speak more directly to, like, do we have evidence for an association, right? So we can speak more specific to what's meant for this, but that's what we'll do next.
Why do I think the equal low versus five,
But one more time.
like when we're doing strategy, we're doing like moderation with regression, and we don't want to do like big top lines and saying it high level and low levels. Like, why are we anchoring low and high still max axis? Like,
Because it's,
tempting.
oh, on the x-axis, it's just an arbitrary point, right? This is just standard deviation below standard deviation above. We can go 2 if we wanted to, or like, it's just kind of a convention to say this is kind of where we're at within a standard deviation, right? Now, the thing you got to be careful if I go down to 2 standard deviations or 3 standard deviations, things start to look pretty extreme on those on those ends. But the question is, do I have representation out there? Like, I have a point estimate for what people should fall on if they were at that level based on this model. But if I don't have a lot of people out there representing that, that starts to get really precarious, right? And so this is why we're never looking at, like, is this a difference? Yeah, probably, if we were. But is this a difference or is this a difference? I don't know. So that's not the purpose of these analyses. This is an arbitrary point on a continuous scale, and so where things fall in are probably not terribly interesting. If we want to, just because this has come up, Sam, and it's a good question, we'll get here. Okay, so here's our simple slopes. This is from Layla's thesis. Here we've got through looking at the extent to which empathy moderates the association between PTSD symptoms and social functioning, right? And we find evidence of interaction where people were scoring at low levels of empathy, standard deviation below. Yeah, we have a negative association between PTSD and functioning here. But for people at high levels of empathy, standard deviation above, looks like PTSD isn't related to social functioning at all, right? And again, we're not looking at differences here, we're looking at the strength of those slopes, right? But the question is what is the standard deviation above or below empathy mean on this, and why is standard deviation when we're talking about 2 standard deviation, about half standard deviation? And so this is where we get into plots that are much, much more informative for these Johnson-Newman plots. What we have here is this is the effect of empathy, and this is the conditional effect of PTSD on social function. So what we've got here is we've plotted the conditional effect of PTSD, that slope of PTSD. This is giving us the coefficient for PTSD and function across our whole range of empathy, right? Empathy is our moderator here. Empathy ranges, we got empathy scores ranging going from 0 to 9. This is the conditional effect. So this isn't, this is saying if I were to say right here, so that for empathy scores of 3, right? This coefficient represents the association of PTSD and social functioning for people who have a value of 3. Now this is a negative relation, so this is saying that yes, PTSD holds a negative association with social functioning for people at this level. For people at this level, we still have a negative value of something that's slightly less than 0. But if we look at the confidence bound for this point, it contains 0. So looks like at high levels of empathy, there's not an association here, but at low levels of empathy, there is. But what we can do with this graph is start to take a look at saying where exactly, what are the bounds? At what point does, at what level of empathy does PTSD stop having a relation with functioning? And it's probably going to be right about here, right? Because this is where our confidence bound starts across this 0 line. And so we can say, yeah, for values of our moderator up to about 6.75, PTSD holds a negative association with functioning, but once we get to this level, then it no longer probably does, or we just we passed our threshold for evidence here. Okay. If you're having trouble seeing this, that's fine. This is a tricky thing until you get a good handle on sort of what's happening here. But this is sort of plotting, and again, this line right here, this is just your B value. This is just your simple slope. Here we've got negative simple slopes to 0 simple slope. Here's your confidence bound, and so go up and start trying to find a point where that confidence bound sort of crosses over 0, and that's kind of the limit. So we can say this, as opposed to this, we can say, yeah, there are periods, if we look specifically at a negative relate or at a standard deviation below empathy, PTSD has an association, a negative association with PTSD or with social functioning. At a standard deviation above empathy, PTSD doesn't have a relation, but I don't know what's going on there. Right? This is a more complete sort of saying these are the boundaries of this association. From this point to this point, we've seen a negative effect. That negative effect is getting weaker as we get closer and closer to this point. After this, at least in these data, we no longer have evidence for an association. Right? So this ends up being more informative, so long as you know how to interpret it. But it's also much more difficult to go through computationally. It's an iterative process and things along those lines. This I can do by hand off a basic regression with algebra. This takes a little bit more effort to go through and sort of put this stuff together. But again, given the tools at our disposal, this starts to become, I would make an argument for a more informative way to go through these, but for latest thesis, we'll go through, submit it, and that public meeting will say, hey, people, if you want to just take a pick a point approach, we're just looking at high and low levels. That's what this looks like, right? But if you're really interested on boundary conditions, which is kind of what I would argue is the more interesting piece of things, this is what the unique effect of PTSD on social functioning looks like across the full range of empathy, at least as it's been measured in this model. And so it's going to go through, and it's going to be negative until we get to this point, and then our confidence bound sort of crosses lines. So we would say that we don't have evidence for a relation of association of unique effect of PTSD and social functioning once we get to about people who are 6.75 on so that help kind of yes, and what you're saying is all the reasons that people are the reasonable criticism that people have had. This is fine, this is nice. But if you want to know sort of where this is going, like I said, if you look at the slope line, it's a linear function. So like as we go through, so as you increase empathy higher or lower, if I want to know what the effective PTSD and social functioning is at average levels of empathy, it's going to be the bisection of this, right? So it's just a straight linear function. Now we can have a question about whether or not there's a linear relationship on that, and then that gets into a whole different type of thing, but it's what we're at with this. Okay, sounds good. All right, cool. Keep after it. Let me know with this regression assignment if anything comes up. I'm going to be tied up in an assessment Thursday from 2 probably through 5, so I won't be allowed to be in my office, but the door will be shut and I won't be available. But shoot me questions or things along those lines, or CJ is a magnificent resource for this stuff. So just make sure you're getting questions answered if things come up with that assignment. Thanks, everyone.